Petri got first. Congratulations. As always. Oh, rip. Make sure the YouTube stream is good. Oh god. Why is it blacked out on my screen? I think it's just not loading right. Refresh. Come on, YouTube. Hey, Thunder. Oh, wow, Jed. Okay, one second. Okay, here, look. In the meantime, there's something that I'm very excited for, which is I went on Etsy and I refrained from buying every emote that was on there, but I did buy quite a few new ones. Let's see what we're working with. Are these all the new ones? There's one that I'm missing. I don't see it on the list. There is that many. There's a sixth one that... Which one is it? It's the ghost one. Did it not come through? Did I not assign it to a slot? Oh no, I think I need to refresh. Okay, I am live on YouTube. It's just not showing up in my little preview for some reason. Okay, we're good. Do I see the ghost now? I do. New emotes. There we go. The little cat in a blanket is like easily my favorite one. I love its little face. It is the most adorable thing. But anyway. Okay, so I was going to start off the stream today with looking at a conversation I was having yesterday that I kind of had to cut off, unfortunately, because yesterday was a hectic day. But this person popped up in chat. I still don't know how to pronounce it. They posted two different questions. I posted the solution to one of theirs, and Talos actually got the other one, thankfully, because I was stuck on it. And I want to just go through and see, because they asked some follow-up questions, and I just didn't have time this morning to go through it before the stream, so just do it on stream. So their first question, it's going to be hard to read on stream, but it was basically number 15 here, which I rewrote. It's the top line here. You just have to... The question is, how many solutions are there for X? I solved it and just found that there was one solution. But apparently, the answer is 0 because they're working on the domain to infinity, which I didn't see in the question, but I'm just going to take that as what it is. But it looks like there's an outstanding question on the rational function, or oh my god, it's I would call it a rational function, but it also has square roots, so I don't know, is that still considered a rational function? Let's see, is this the... No, I think Talos did a step or two before. So let me... It's... Okay, yeah, this one right here, this beast of a fraction involving square roots, it's probably still a bit hard to read, but you just have to simplify it, and it is not easy. And Talos got 1, apparently that simplifies 2, and this person is saying that 1 isn't an available answer. I didn't see a problem with Talos's work. I went through it, and I agreed with it. Solution is -1/2. All right, let's look at their solution that they posted here. Let me make it bigger. That's the one on the top. The thing I don't get is how we get root a-1, a+1 times a-1 minus a-1. Let's... Same question when I'm done. Okay. So, okay, that's the first one up top here. So this is the original problem right here. Okay, so they just rewrite the fractional exponents as square roots. That's fine. They factor the numerator. and they multiply out the denominator. This is what I was trying to do. I kept getting stuck though. So let's see how they apparently don't get stuck here. Okay, so they multiply out the a minus 1 squared plus the a minus... Oh, sorry, the a minus 1 squared and the minus a plus 1 squared over here, and you get a bunch of cancellations. You get still a minus 2a and a minus 2a. Really? Did you get that? I made a mistake very early on in my work then, that I checked it so many times. What? Did you get that cancellation? I didn't get that. Why did I get that cancellation? Was I just not paying enough attention? So wait, what happens with the radical here? They factor out the radical and we get a plus 1 minus a plus 1. Okay, they were asking about that step specifically. You end up with a minus 2 in front. Okay. I don't know what I was doing wrong. I erased the work that I was doing a long time ago, as in last night. But I understand this step, so let's explain that to the person. Okay, so flip back over to Discord. Let me get that on a second screen so I can copy as I type. This is actually, it's herbal tea. I do drink coffee every morning, but I usually do it before I start the stream up. They did is a dawn drinking tea emoji. I don't know. I've kind of been avoiding emotes that are of my face because I feel like it's what everyone has, I guess, but I don't know that my emotes are that unique for it, so I don't know. My emotes don't really have a cohesive theme, I guess, or it's kind of random stuff. Is factor, what do they factor? A minus 1 slash square root, curly braces, a minus 1, a plus 1, and curly braces, minus a plus 1 slash square root, curly brace, a minus 1, a plus 1. 2. Slash square root a minus 1, a plus 1 times a minus 1 minus a plus 1. And simplified from there. See how that LaTeX renders. That's not... Wait, why did that square root not work? Oh, I didn't do the curly braces. Ugh. Okay, I think that addresses the outstanding issue here. I don't know why Talus's answer is wrong, but I don't want to dig through this algebra again. I did this problem I did probably 5 separate fresh attempts on this problem last night. And then Talus also attempted it, and I didn't see a problem with this, but I guess it doesn't match the answer. I'm kind of done with digging into it, though. It's so much work. Let's look at what Thunder posted. Let's rotate it. Question 4. You're not sure why minus 8 over 5 is not a solution. Booted? You sure are first. Okay, so question 4. The sequence with recurrence relation. Oh gosh, recurrence relations. U sub k plus 1 equals p u sub k plus q. U sub 1 equals 5, or p is a constant, q equals 13 is periodic with order 2. Oh no. I definitely do not know this offhand. I'm not strong on recurrence relations, and especially a periodic recurrence relation. I'm going to do some Googling here. Periodic recurrence relation. Equal the first 3 terms and make the first term. 5 equal to the third term. Is order 2? Is that every 3? See, I don't even know that much. If our recurrence relation is order 2, I would assume that it's 2 terms, and then it repeats 2 terms, and then it repeats 2 terms. So, if it's actually 3, I don't know, I don't get why, but I can go with it. Okay. I think second order relation means that, yeah, you have 2 terms, but the period is second order, I guess. Oh, I see. Okay, no, so I was thinking about it correctly. I was just getting mixed up with like the indices. But yeah, it means that like a sub n is equal to a sub n plus 2. Okay. Give the first 3 terms and make the first term. A-Y-E-S, okay. So I think I just need to go to the board and kind of hash this out a bit and do what you said with getting the actual terms here. It's an easy ego boost question. Oh gosh. I sure hope it is, Thunder. I could use it. So you said, I'm a little bit confused why they're using like Q and they just said like Q is 13 as well. Why not just say 13, but I'm not going to question it. Q is 13, right? Oh, it's because I'm too zoomed in. They're weird like that? I guess so. Okay, so what we really have is u sub k plus 1 equals p u sub k plus 13. So if u sub 1 is 5, that means u sub 2 is equal to p times 5 plus 13. This feels a lot like the Euclidean algorithm in reverse, but I think it's probably just coincidence. Oh, I see where you were saying with the quadratic. So that means u sub 3 is going to be equal to p times u sub 2 plus 13. And we know that u sub 3 should equal u sub 1. Okay, that's not too bad. And I assume that if it's a quadratic, we're going to get two solutions and one of them isn't right. And that's where your question is? (13 minus 5 is 8, last I checked. Oh, what an annoying thing to factor. 40 and 13. We have 10 and 4, 20 and 2, 8 and 5. Oh, 8 and 5. Okay, maybe it's not that annoying. So we have an 8 and a 1. They should both be positive. Well, I guess the 1 has to go here and the 8 has to go here. And that's where you get the minus 8 over 5 from. Okay, so yeah, one of these solutions is wrong. You said it's the minus 8 over 5. Well, I guess the only thing I think to do is to plug it in and just verify it manually. So u sub k plus 1 is equal to minus 8 over 5 u sub k plus 13. And u sub 1 is still equal to 5. So u sub 2 is equal to, that's going to be minus 8 plus 13 is 5. U sub 3 is, oh. Are we just always going to get 5? Is that periodic of order 1 then? Is that why it doesn't work? That must be why. Yeah. That's really funny how that doesn't work. Okay. I don't know if there's a better way to tell other than just plugging and chugging, but that seems to be the answer. I don't know how else you would possibly do that. All right. That's kind of an interesting question, I guess. Once you give me that hint of how to do it. I'm glad I was able to help you out with that. So yeah, it does give you a valid recurrence relation. It's just not the one that they asked for, I guess. Technically, I should check it that p equals -1 does work, but I think you already understand that part, so I won't go through and like fully answer the question to that level. Okay. Ego plus 100. They say p is a constant. So if they said p is like an integer, then yeah, but I mean that's not a bad thought though, that because it's a decimal, it might not work because of that, but in this case, no, it's just the wrong period. It is basically that same like issue though, where it's a valid thing, but it just doesn't fit what the question originally asked for. Okay. If I were to keep them coming, I do see I have a comment over on YouTube. Hey, Anshuman, in a right triangle, how to know what is perpendicular? Depends how you're given the question, I guess. Like I'm assuming you're given maybe like the length measurements. So I guess I'll interpret this question in two different ways. If you're given an actual picture, it's kind of a bad solution, or it's kind of a bad thing to say, but I would say just look at it and the right angle is the right angle, I guess. But I assume that's not what you're actually asking. I assume you're being given something like side lengths 3, 4, 5, for instance, and you have to check if that makes a right triangle. And what I would do in that case is verify it with the Pythagorean theorem, because there's only one way the Pythagorean theorem will work. And the hint is you always want to choose the biggest one to be C. So I'm going to take 3 as A, 4 as B, and 5 as C. Always take the biggest one as C because that's your only shot. So I'm going to say, oops, by Pythagorean theorem that A squared plus B squared equals C squared. Only right triangles follow this, so if A is 3, we'll do 3 squared plus 4 squared equals 5 squared, and 9 plus 16 equals 25. 25 equals 25, so this does make a right triangle because it follows the Pythagorean theorem. I think I hope that's what you're asking. And so in this case, how we'd interpret this is 5 is the hypotenuse. A and B are always the smaller sides, like that make the right angle. So once we know this, we'd say 5 is the hypotenuse, and then you can take your pick for 3 or 4. You could also switch these around all you want, as long as the 5 is up there. Either of those are valid drawings. All right, glad to help. Have you seen questions combining Poisson, geometric, and binomial distributions? I don't think so. All 3 at once? I don't know what that would be. The last beard on Twitch, stay strong. I don't know, dude. We need Anders to do a beard reveal, because I'm kind of scared now. He said he has a beard down to his belly button, and like, you know, there might be a new challenger. And no worries on Shimon. All 3? I mean, do you want both just so I can see it? If not, it's all good. He's got a wizard beard? Yeah. This is just tea. It's throat coat tea. I know I drink it before the stream, but on Real Analysis days, I don't have time to like brew it before the stream starts, so it's a bit teenager-like. Should I tell when you're sick, dude, this stuff is it doesn't, it's not a cure-all, but it does help a lot. Let's see what this is, Thunder. Hey, Skirtle. I'd say that is 2 times due. Call me Patch of the Pirate because you can't grow it all. It means you just have to push harder. You know, if you can't grow a beard that you're happy with, you just need to like push, like. That's how it works. Boo. The number of faulty. I remember Dan doing almost the exact same problem. Like at least a month ago, probably like 2 or 3. And like there was some weird thing with the wording. Actually, you know, Poisson and geometric. Actually, and maybe it's not that weird to have a question like this, because Poisson is related to or like Poisson's a special case of a certain type of other distribution, I think, or something like that. I can't remember exactly. Or geometric is a case of Poisson, but Poisson is very related to another one. It's definitely less dense in your cheek. Yeah, like my little I feel like my mustache connectors could be like a bit better. And I wish that my beard didn't grow down like so far down my neck, so I have to shave that every day. But other than that. The factor works for 7 days each week. The number of faulty components per day are monitored for a period of 2 weeks. It's a 2-week period. There are at least 5 days with more than 6 faulty. Oh no. That seems like the binomial one. Because you're fixing the period of time. Okay, so I this is not all three like simultaneously. Like use a binomial distribution and a Poisson at the same time to do something. I guess it's like the same situation, looking at it from different angles. The term neckbeard doesn't exist over here, so you let it be. I mean, I gotta move to Brazil then, so I don't have to shave. That's the solution here. Yeah, this is super wordy. At least 5 days with more than 6 faulty components. So we would need the probability of more than 6 faulty components, which I think would fall from something from the... Oh, I guess that's part A. And so yeah, the 100, you already have a good like handle on this one, right? Or was there a part that you want me to actually like go over a bit? So I was just kind of curious to see what it was like, but also, hey, pro moment. Oh, so you do want to see this worked out? I'm gonna have to Google some stuff, but I definitely do know this. You need help? Okay. Hey, Bookbinder, how's it going? Okay. Yeah, Dan, I think what you said is going to be the answer for D. I guess well, let's start from the top here, though. Long time no see, exactly. Hope you've been good. Probability on any given day, at least 6 faulty components produced. Okay, so what the heck is going on with Poisson again? It's been a minute since I've done anything with Poisson. Do we want to look at this one? Let's see. Occurring within a given time interval. Mean 6. Then that's for 1 day. Oh gosh. So faulty components on average 6 per day, and we're interested in exactly 6 on a given day. Is this not? Is this the geometric? Oh my gosh. They don't define what X is? I assume X is just the number of occurrences. I think we do want Poisson. Let me try a different Poisson calculator. Just cut to the chase. Lambda 6, X 6, 0.16. Now, I don't know if that's how you're supposed to do it for your purposes. Thunder, but I think we do just do the Poisson, which we should get the same result if we plug it into the formula here. Just use a calculator. Exactly, Dan. Hey, Tushar, over on YouTube. Just use a calculator. I mean, exactly. Wolfram Alpha can't solve it, then neither can I. So not greater than or equal to 6, because they say exactly 6 faulty components is how, yeah. And if you're not able to just use a well, I guess okay. Good luck calculating that by hand. But we could do the actual formula too. Hey, Anders. It'd be e. Let's get the fraction bar first. E to the negative lambda, which is 6, times lambda to the x. So just times 6 to the power of 1, if you want to say that, over 1 factorial. Bookbinder, I absolutely remember you, yeah. Calculator's fine? Okay. Wait, why isn't it the same thing? Oh no. Oh wait, is that... No? Wait, I said x equals... Well, why did I say x equals 1? X equals 6. Point one, there we go. Okay. I just don't know numbers. I think this formula is for exact values of x. So if I do x equals 6, it's for exactly 6, which is what the question asked for. And down here with the summation is where you get the multiple. As for part A, it's exactly 6. And Anders, class was great. We basically proved the intermediate value theorem was like the biggest thing. Take a save away. Yeah. Deduct 1 save from Dan. And then we like very briefly touched on what it means to be uniformly continuous, which is a super weird definition that I'm probably going to try and go over again later today if there's time. Anders the beard. Okay. Yeah, I can briefly show it. I mean, I guess it's technically a spoiler for anyone who's in section 2, but I'm just showing what the question was for one of these. So it's not really that big of a deal, I don't think. Yeah, we like just briefly touched on this. We didn't do it rigorously, but looking away from Twitch. I'll put it back down in a second, but yeah, that was like an interesting one to work on because I still don't completely understand it. I have like half an understanding, I feel like, and I'll take it away in like 5 seconds. All right, it is now away. I'm not showing the questions anymore. Okay. So, okay, I should do some bookkeeping here because I'm going to forget our answer to part A, and we're going to need it at least for part D, if not more. Already unsubbed and unfollowed. I get it. I don't blame you. Okay, so for part A, I guess we'll round it off to 2 decimal places. I feel like Thunder, your questions have been so like particular that they're gonna be like, oh, you should round it up to 3 decimals. But I'll just do 2. Unless you know that it shouldn't be. You know what, Dan? If you want to unsub and unfollow, that's definitely your freedom. Teacher says 4. All right, we'll do 4. 1606. Let me get my mug away too, because I'm a lot of tea. Ugh, that last sip was terrible. Okay. Hey, Bob. Which you recall is related with delta being dependent just on epsilon, but not the point x. Yeah, it's like you have to have one universal delta for any xy pair. Something like that. All right, so we're going to part A then, Thunder. Let's look at part B. Probably over 2 consecutive days, a total of at least 10 faulty components. So that's where we're getting into multiple days. And so how... Oh, okay, Anders. Mustard watches? No. Okay, so how does this evolve when we change the time interval? Do we just say that we're expecting 12, an average of 12 over 2 days? Is that a math term, Budib? P of x equals 10 times 2? Well, it's the total across the 2 days is 10, so it could be 5 and 5, it could be 10 and 0. But like if P of x equals 10 times 2, I think it would be 20. Like, okay, I don't want something weird to come up, but like, what the heck is a mustard watch? Oh, okay. I just want to make sure that there wasn't like... You're not talking about color? Okay. Yeah, I don't know then. A watch? Yeah, that's what I was imagining, Dan. I don't know. The first link? Oh. An integrated approach to time and food of watch and of mustard pot. Deliver mustard in any desired quantity and still display time with precision of 30 seconds? What is this? Who is it? Is someone actually studying this? I feel like this has to be a joke, right? Proposal of ketchup watches somehow misses the point. Whereas Dijon mustard is so strong that we can content ourselves with very small quantities, a ketchup watch should be big enough to harbor at least 1 teaspoonful of ketchup. It'll be more realistic to call those watches clocks for want of portability. Oh my god. Alright. I don't know how you find that, Buddha, but I appreciate you. It's a watch that dispenses mustard. Okay. The more you know. Okay, so Ig Nobel Prize. Yeah. I'll drop a link in chat too for anyone who's being especially like studious and wants to learn about mustard watches. What is a geometric distribution again? See, that's something that Thunder mentioned, and I only like half. No, I'll give myself like I remember 10% of it, which is that they exist. That's the 10% that I remember. It's a calculator. Isn't it? It's a Poisson, but only the first one occurring or something like that. Like how long you go until the first one? Is that it? Oh, okay. Number of trials until the first success. That's right. Okay. And I don't... Oh, yeah. So we probably won't need it, as you said. So... For like part C, Thunder, I would say that we probably want P of x equals 6 times 2. Probably. For part B, we have some combination stuff going on, I feel like. Because you could have 10 on one day, 0 on the next, 9 on one day, 1 on the next. And I want to see... And it's at least 10, too. So changing time interval. I just want to see how the Poisson distribution changes with okay, this is basically the exact question that I have here. If you're given 100 customers an hour, can you say that it's 50 customers per half hour? X minus probability of 12 for 2 days. X minus, I don't understand what you're saying, I don't think. Oh wait, you know what? I don't think we're doing times 2. I think we square it. It's for part C. For part B. Squiggly sign. Oh, okay, plus on 12. X squiggly sign plus on 12 for 2 days. I think what you want is the tilde, like, do shift and then the key above tab. But it's not important, so I know what you're talking about now. Okay, I feel like I'm confusing myself because I've been talking about B and C, like, alternately. Are you saying 12 because of part C? Or... maybe you're saying... so the 12 is coming from the mean is 6. Oh. That might work. That's basically the question that I'm asking. Or that's basically the question that I'm trying to, like, figure out, I guess. So I think for at least that would work. For exact, we might have to do what I said, where you... in 2 consecutive days. Huh. I think that is what we're gonna do, Thunder. I just want to look at this site, and if this site also confirms it, I think we can go ahead and just take that. Ooh. It's a more complicated version, but I think it's doing the exact thing that you're asking about. Events per time times time period. Yeah. So in this case, we have 6 events per 1 day times 2 days. So we do 12. We do. Okay. We got to be careful the p of x greater than or equal to 10, which is also 1 minus p of x less than or equal to 9. So yeah, if we were to go back, we'd make our lambda 12 now, and we're interested in x in 10 faults, at least 10. So if you're doing a calculator like this, you can just do the greater than symbol. I think on calculators, they normally only do less than or equal to, in which case you would want to do it with 9. 0.24, is that the same thing that I got? Oh, you'd have to do 0.24 minus 1 to get that. And it does work out. Calculate. Okay, so yeah. Let me do it the way that you should then. So I do it with less than or equal to 9, but you have to do 1 minus this, importantly. Because you have to negate the probability. So 0.7576. Which, that seems like a reasonable probability. Because that's, you're going just below the average and then doing at least that much. So that it makes sense that it's above 50. 7576. Yeah, it's a tricky thing, Thunder. Probability in general is really tricky. Okay, so this one, exactly 6 faulty components on each of 2 consecutive days. Now for this one, I think that we'd want to take our answer from part A and square it. Because it has to be exactly 6 on each day, so we can't allow for like different combinations that add up to 12. It can only be 6 and 6. And part A is exactly 6 on one day. And so you just want to do 1 day and 1 day, and they're independent, so you can just multiply the 2 probabilities. And they say 2 consecutive days, so you don't have to worry about the probability of it not happening on a day in between, I think. So what I think, 1606, we just take it and square it. And I think that's our answer. Do you have the actual answer key for this one? Because I'd love to have a verification for being right, I hope. 0258. Oops, that's not, oh God. No clue the answers are? Oh gosh, okay. I'm pretty sure I'm right. I don't see why I'm wrong, but that's also, I say that all the time with probability questions. At least, are exactly 6 faulty components produced on each of the 2 consecutive days, so yeah, I think this is honestly, it's a bit more like a binomial. Or like, no, maybe binomial is the wrong thing to compare it to. You just want the probability of 2 events happening simultaneously, and when they're independent events, you just multiply them. That's how I'm interpreting this question. We have 1 day with exactly 6, 1 day with exactly 6. If it wasn't 2 consecutive days, it depends on how exactly the question is phrased. But let's say exactly 6 on 1 day, anything but 6 on 1 day, and then exactly 6 on the 3rd day. You would do the probability of exactly 6 on the 1st day times the probability of not exactly 6 on the 2nd day times the probability of exactly 6 on the 3rd day. So they could phrase it in some other like different way. At least for the way that I phrase it, yeah. Okay, I'm glad enough to like see the pattern at least. So it could be like, you know, exactly 6, then at least 5, then exactly 7 or something, and you just have to find those probabilities. Currently doing test cases with different tonic waters to figure out which one is better. Ooh. Interesting, interesting. Okay, so let's look at part D. This one I was saying is likely binomial. The factory works for 7 days each week. The word math demon. 7 days a week, dude, geez. Number of faulty components per day are monitored for a period of 2 weeks. Oh my God, okay. Find the period that in this 2-week period, there are at least 5 days with more than 6 faulty components produced. So we need, this is binomial because because it makes sense to me, and that's all the explanation that you get. No, I feel very certain it's binomial when I'm trying to figure out the words. What jumps out to me here is that we're given a fixed period of time of 2 weeks, which is like our number of trials. Sorry, it's that ambulance or whatever, you can hear it. We're asking about a certain number of successes without regard to order over a 2-week period. And the probability, or like the number of faulty components is kept constant? Well, more than 6. We could find the, oh my gosh. But anyway, because I said so, yeah, exactly. Chalkboard is fluorescent under UV? I didn't know that, that's weird. Trials are independent, yeah. And each day is a trial, and there's no reason why one day would affect the next as far as we've been given. Really, it shouldn't, like if there's a fault, then maybe there's a fault in the machinery, but it's, you know, that's not what they put in the question, so. It's binomial because each day is a success or failure, depending on whether they have made more than 6 faulty components. I think that's the, like, it's the success or failure part of this. We don't care if it's 7 or 8 or 9, we just care that it's more than 6. Yeah, so each day is a trial, Thunder. And so over 2 weeks, we'll have 14 trials. That's 14, guys. I don't know, is that 14? I don't know. It doesn't matter. So yeah, it's 14 trials in the entire day. It's a success or failure, depending on 5 is 14. Yeah, thank you, Thunder. Okay. So yeah, this is one where I've just done enough of these problems where I guess I have the intuition, but it makes it hard to explain it to someone who hasn't. But yeah, it's just something where Poisson, it would not work. Like if you tried to do Poisson with this, good luck figuring out, like you could say you're expecting 6 times 14 whatever faults over the period, but it wouldn't address the at least 5 days part. Okay, yeah, Dan, we had the exact same thought. That's a better way to explain it, I think. Yeah. So, just to get good moment, I mean, kind of, but if you were, you know, if I was a student and I'm not that comfortable with these distributions, which I'm still not that comfortable with these distributions, the first thing would be what you would do is probably try Poisson with this. And the issue that you would run into is capturing this at least 5 days part. Because you could get, using Poisson, the probability that you get in total 6 times 14. I don't know that offhand because I'm bad at math. 84. You could use Poisson to get, like, you know, the chance you'll get 84 faulty components over that 2-week period. But that's not what the question was. That would be like on average if you have more than 6 faulty components produced. But we want each individual day having more than 6 faulty components produced for at least 5 days. Cycle method is a tool. Which tool is best for each situation? It doesn't work with the Poisson tool, so we have to look elsewhere. Yeah. Yeah, dude, that's what I was like trying to say last night with that trig thing that you were working on. That like harder algebra way is probably the better way to teach a student because it's a lot more generally, it's a much more generally applicable tool. Oh, it's also cool to show that like good tricks so they know it. But I feel like it's only the same idea where like we have an advantage in having done these problems enough that we just see it. So can't figure out what Poisson does if you have to describe it. I mean, honestly, I had the same issue, which is why I had to Google it. If you have a situation where, well, I guess we can even use the problem as an example. If you have a factor that on average produces 6 faulty components per day, Poisson answers the question of what are your odds of getting 8 faulty components in a given day, or at least 8, or at most 8, or 10, 4, whatever number you want. X equals 0, 1, 2, I guess. Putting this in a Poisson question. Okay, so I know that I've been like going off the rails with describing a million different things. But Thunder, so I don't believe I'm just confusing you more because I probably am being confusing. Poisson, you would use Poisson to answer the question of, on average, or if they were asking the question, what is the probability? Oh, I kind of want to like write this down. Okay, here, let me just because I feel like I'd be able to actually like see the text. Continuous versus discrete. It's because you can't have half of a faulty component. Oh. I guess Poisson, the function is continuous. But I had you backwards with the discrete versus continuous thing. Okay, let me. I'll try and see the bit that I'm saying, and then maybe we'll turn to Google to see if there's a better explanation. Or maybe let's just go straight to Google. Let's go straight to Google. So maybe it's a question that's been answered before. Because this is an important thing to know. When to use Poisson distribution versus binomial distribution. That's a way that you could think of it, Thunder, where Poisson. Oh gosh. So looking into further extension is a domain of values. So I think this is what you're getting at, Thunder, where like Poisson is, there's no hard cap on the number of potential successes, whereas a binomial is capped with the number of trials. I don't know if that works for you, then great, but that's think about it in a different way. So I guess let me. This is true too. Actually, let me see what the answers are. This ain't working? All right. I don't blame you. I blame myself because my explanation isn't very good right now. Okay, so let me go back to what I was thinking originally, and I'll type out what I'm saying as I'm saying, because I feel like it's something that's helpful to actually, like, if I just say it verbally, it'll be harder to follow it. So you would use a Poisson distribution to answer the question of over a period of 2 weeks, what is the probability of getting at least, we said it was 84, which is 6 times 14 days. $16 faults, or faulty parts. Getting at least 80, yes. This is, we can't get any finer detail than that on average over the entire period. That's as detailed as Poisson distribution can get. On average, over the entire time period, Poisson cannot get into the detail of how each individual day goes. A binomial distribution, though, can regard each individual day as a success or failure depending on a given criteria. Here, number of faulty parts greater than 6. And so there's a third point that I want to make here. I'm still working on the phrasing of it, though. A Poisson distribution makes it convenient to I'm trying to get at kind of what you were saying, Thunder, where Poisson can go out to infinity with the number of, successes, or in this case, faulty parts. The number of faulty parts you get over a time period, whereas a binomial distribution is not convenient for varying the number of faulty parts. Hence why, or which is why we're given, I don't want to say hence, this isn't a proof, which is why we're given a condition of more than 6 faulty parts. That always stays the same. Seeing I'm not completely satisfied with this explanation, but these are the thoughts that I was having when I first saw this as to why it's binomial. Let's see what Dan is saying. For every trial in a binomial distribution, there can only be one success. So at most, we can have a 100% success rate. Poisson doesn't have individual trials, just continuous for a time period, and the number of successes in that period would be hypothetically infinite. Yes. I'll just post this too, but So like part A is Poisson because this question could very well be about 8 components, 10, 1,000, and a million, as high of a number as you want. But part D, the question becomes entirely different how you calculate it if they wanted more than 7 faulty components per day. Or the work between part 6 and part 7, or between 6 and 7 faulty parts would be the same process, but entirely like new numbers and nothing from before is applicable, I guess. I don't know. I feel like I'm explaining it. I think I'm dancing around it, but I'm not getting at the heart of it. Okay, yeah, that's a nice way of saying it, Dan. Because our number of, we're thinking now about success in terms of the days with more than 6 faulty components. You don't know you're questioning everything? Everything that you've put so far, Dan, is consistent with my understanding. That's a good question, Thunder. Which is another thing that I would say it just makes sense to me. And I know that's a horrible explanation. So I like the real thing that the question. How about this? When we started this question, we're in Poisson land, just looking at the number of faulty parts. Yeah, the 2 6s are kind of confusing. But Dan, I think Thunder, that's about the 6 that's included in part A, rather than the average, including the original thing. In part, so it, oh my gosh. Okay, so how do you know you're in Poisson land? Are you like in the Matrix? That's true. Oh my gosh. Okay, so in part A, the thing that we're measuring is the number of faulty components. And in part D, the thing that we're measuring is the number of days for a given number of faulty components, which is a slight distinction. But maybe it should be enough to trigger like, oh, maybe I shouldn't use the same distribution. Because the thing that we're measuring has now changed and we need to adjust the math that we've been doing. Now, how do you know you're in Poisson land in the first place? Is because you're only given a mean of 6 for a given time period. And so if you see a given time period and just a mean, that should always mean that you're in Poisson land, I guess. And so, okay, maybe this is a better like train of thought where at first we're measuring the number of faulty parts and we're measuring the number of days with faulty parts down in part D. And well, it becomes binomial because we only care if it's more than 6. So it's like it becomes like a binary condition, basically. Oh, gosh. Wait, you think part D is Poisson? Oh, no. What? How? If you want to actually like talk as well, let me know. But oh, okay, no worries. Whoa, 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 whoa. It would be binomial. Ah. Oh God, this is. You see where you started, Thunder? So, in a binomial distribution, you have nxp like that. I might have the order slightly wrong. In this situation, n is 14 days, x is 5 days. P is a probability of more than 6 faulty parts. Because more than 6, it's you're either more than 6 or less than 6. So it's like, you know, Q is less than or equal to 6. That's why I think binomial works here. Get up in the matrix. um if we were, I mean, maybe this is, I'm kind of scared that Dan is like disagreeing and that Dan also has to leave. You're in Discord? Okay, okay. And no need to stretch if you don't, it's like, you know, your job is more important. Let me just fix my mic in Discord. Hello?
Hello, hello, testing, testing.
I gotcha. All right. Why is this Poisson?
Okay, now I have to be very specific and say that disclaimer, I am guessing, but I am more confident in this guess than I am in anything that we've discussed so far. Okay, so I'm not speaking with authority. I think that this is an idea to consider. And I'm sorry for being quick. I'm at work. I'm not supposed to be here, but like, oh well.
Yeah, if you have to leave, like, please do. But
no, hopefully nobody at work can like hear my voice and is like, is that? What's the nature of binomial distribution? That's the simpler one. So let's think about binomial. If I have 16 days in a binomial, or 14 days for 2 weeks in a binomial distribution, what is the maximum number of successes I can possibly have? Well, if it's 14 days, I can have 14 successes, because binomial is either there's a success or there's a failure, right? So what I've been seeing for Poisson distribution is you can have multiple successes in one like time period. The time period is actually arbitrary. It doesn't matter if you measure it by the day or by the minute or by the hour or by the week. We don't care. So the best example I can think of is like traffic. If you're like sitting in your house and cars are passing by, you might know that there's an average of 5 cars that pass by every day, right? Like that's the average. But within one day, there could be 3,000 cars that pass your house. And it's like, what the hell is happening? And it just turns out that like traffic got rerouted down your neighborhood for some reason, or there was an accident or something. So the reason that that ends up being Poisson, the example that I just came up with, is there's no cap to how many successes you can have. You could hypothetically just keep having them. There could just be more and more and more and more and more cars, despite that being like way higher than what the perceived average is. So in this example, that's kind of the hard line that I'm drawing between the two. What is the maximum number of successes I could possibly have? Is it bound by the number of trials? Is it one success per trial? Because if that's the case, it's binomial, no question. But here, they're saying that the number of faulty components produced on a production line per day, so they are setting up like a hypothetical time frame daily. They're going, oh, we can already have more than one success per trial. We can have 6 failures per trial or 6 successes per trial. That immediately violates binomial distribution because binomial can only have 1 success per trial. Like that's by its nature. Binomial can't have more than 1 success or failure per trial. So if we can have 6 of the thing we're looking for, I keep calling it successes, but it's like faulty components. That's obviously not great for the company. But if we can have 6 faulty components, and that's just the average, that means we could have 7, we could have 8, we could have 12, we could have 24 faulty components in a single day. The machine could break down and like everything could fail. Thousands of components could fail in one day, just like thousands of cars could pass your house in one day. So the number of interesting events, successes, failures, whatever you want to call them, is not limited to the sample size. It's not limited to the number of trials. It could vastly exceed that. That's what I'm seeing for Poisson distribution. And that's my understanding now of what they meant by continuous versus discrete. Binomial is just, I flipped a coin 14 times. Out of those 14 times, I could have at most 14 heads or 14 tails. But for Poisson, it's like I can have 27 heads when I only flip 14 coins. That doesn't make any sense, right? So that's sort of the distinction, I think, between binomial and Poisson that I wanna throw at your brain before I abandon you forever because I have to work.
So if you have to literally just like dip out a Discord call, like please do. But
yeah. Well, what are your thoughts? Because I have some time and I definitely want to get your feedback on that. Because again, I'm not confident, but that's kind of where I'm at.
I still think it's binomial because we can build in that infinitely greater than 6 potentially into P. We can use Poisson to calculate the probability of one day being greater than 6, and then switch over to binomial and look at the 14 days, because binomial ensures it has to be greater than 6 faulty parts per each day. And Poisson would only be able to do it on average over the entire time period. It doesn't assure you of a number of parts on a particular day. That's where I think it's a binomial.
I see. So you would have to do like a translation either way. You would have to like translate part of it to be binomial or like part of it to be Poisson, I think, but you can't do the entire thing in binomial and you can't do the entire thing in Poisson. Is that where you're at?
Yeah, you do need the Poisson to capture that infinite part that you're saying, but it will reduce down to just one constant probability that a binomial can handle.
Yeah. I like that a lot. I think that seems reasonable.
Okay. Awesome. I'm glad we got to the bottom of this.
I think one of the things like to take away for sure is just when do we use Poisson, when do we use binomial? But this example is so confounding because, like you said, we actually have to invoke a little bit of both.
Yeah.
Cool. God, okay. All right. Thank you for having me. I won't bother you guys any further. I'm gonna get out of here, but I'm glad we got some kind of consensus.
Good luck with your student.
Thank you very much.
Bye. Okay. Thunder, and it's completely fine if you don't get this because even me and Dan are like going back and forth on this. Write it down. Yes, Thunder, I can absolutely do that for you. So, and Suki, thank you for your thoughts on this too. I'm glad to hear that you're in agreement with me. Okay, so I'm sorry if there's something I missed in chat, but I don't think I'm too far behind here. Big member teacher doing this question? All right. Okay, so I'll type out a Discord response as I try and explain it. They did what you were saying? Okay, perfect. So maybe we can describe this not necessarily as you can only use Poisson or only use Binomial, but you actually have to use both, and why you have to use both. Malcolm, hey! Nothing much with me. We've been doing stats, which is always tricky. But I think we've gotten to the bottom of this particular question that's been giving us some trouble. We just need to explain why we've gotten to the answer that we've gotten to. So I hope that you're doing good. Okay. For part D, let's split it up in 2 stages. And I think for the sake of at least this first part of the explanation, I'm not going to say why I'm doing what I'm doing. I'm just going to do it, and hopefully seeing the solution makes it a bit more clear why this works. Doing good? Awesome. Into 2 stages. One is determine the probability of there being more than 6 faulty parts on a given day. And 2, there being at least 5 days over a 14-day period with more than 6 faulty parts. Yeah, okay, there's like, there's an even deeper thing that I just realized with Poisson, but I don't want to make it the explanation even worse. So let's not go there. For stage 1, this is a normal Poisson question with x. You said x tilde PO, and then perfect, yes. 6. And we need x greater than or equal to 6. Let's calculate 1 minus p x less than or equal to 5. And let's plug that into a calculator quick. God, this is these questions are really tricky. So we're saying, wait, we need less than or equal to 5. And I know this browser's a bit messed up, but I'll change it back to it in a second. So 4457. Synctronica, I think we are doing that, just not the calculus way. We're doing it the calculator way. So Thunder, I wouldn't worry too much about what synchrotronica. There we go. I just had to sound it out. Sorry, I've been saying it wrong this entire time, but that's the more if you're in a calculus-based stats class, that's the way that you would do it. All right, Malcolm, thanks for saying hi. I understand if you don't want to be here in this discussion because it's not a it's a complicated discussion. It's all we need for stage 1. Okay. For stage 2, we have the probability of more than 6 faulty parts in a given day and want to know the probability of at least 5 days out of 14 having more than 6 faulty parts. This is, you love to stay? Okay. We don't have to lie, but no, I appreciate it. This is like a situation where you're asking how many, or if you're asking for the probability of getting at least 5 heads out of 14 coin flips. Because the probability of a coin flip is always the same. And thanks to our stage 1 calculations, the probability of more than 6 faulty parts on a day is also always the same. It being the same probability for each thing is an important distinction. I might be making it too complicated though, but I'll leave it here and hopefully it doesn't not make too much sense. Or I probably didn't say that right, but you know, just go with it. Okay, so what we have now is x. What's the order for the binomial things? Is it? Or maybe it's npx. That's right. 14.16. Wait. Oh, 4. Yeah, okay, yeah. I was getting mixed up with part A. 4, 5, 6, 7, or yeah. Zach, thank you very much. Wow, you were having a marathon of a stream. The questions must have been rolling in. It's the Husky of streaming. Thank you very, very much, Zach. Welcome in, everyone. The Husky approves. What we're working on right now is the stats question you see on the bottom of the screen on part D, and we've been trying to explain the distinction between binomial and Poisson distributions, and it's turned out to be a lot trickier than I anticipated to actually explain it. So I'm typing out an explanation to Thunder right now, who's also in chat, but I'm putting it into words too, so Thunder can refer back to it. And Thunder, what you just said is, so what I got so far is we're doing X. Hey, Brayden plays. How's it going? 0.44, P of X greater than or equal to 5. Yes, Thunder, that's where this is going to go with the binomial. And when I was talking about binomial, I think you're supposed to like include X, like the number of successes or fails, but we don't need the but it's not that important to me, at least. A music symbol. I wonder if that's a Twitch default emote. No, that seems like something Twitch should have a default emote for. Or maybe if I go over here. Oh wait, there are music notes. If I search music, those are all things that come up. Okay. And we want probability of, for you? I think those are just like general emojis. I had to like go to a weird spot in the emote menu, but it's with all like the generic like smiley faces and all that stuff. I don't know. I don't know. I'm like, or maybe I'm misunderstanding what you're saying. We want probability of X greater than or equal to 5 to get the probability of at least 5 days. At least 5. As you just said, Thunder. And so it sounds like with the calculator, you can only do less than. So p of x greater than or equal to 5 is equal to 1 minus p of x greater than less than or equal to 4 is equal to, let's get a calculator for this. It's going to give me actual binomials, isn't it? Oh no, we're okay. Probably a success on a trial. We said 4, 4, 5, 6? Question mark? 5, 7. Number of trials, 14. Number of successes, x. Calculate. Let's take the greater than or equal to 5 and do 1 minus that just to show the process. $17, 5, 4, 5. That should match one of these. Yeah, x less than 5. Okay. 17, 5, 5. 0.1755. Okay. And I think that's our explanation. So I somewhat intentionally glazed over the why we're doing this part. And Thunder, if you're just like turning in for the day and you don't want to think about math anymore, I don't blame you. So don't feel obligated to try and understand and respond to this now. But what I would recommend you do when you are feeling up to it is just try to... I didn't? Yeah, I did. So I took, and this calculator will do it for you, but I took the greater than or equal to 5, which is 0.82455. And I did 1 minus that over here. You got 1 minus what I got? Oh, I'm bad at math. 4. Greater than or equal to 4, and then you do 1 minus that. And hey, Intisar over on YouTube, I don't speak French. Wait, well, I get 0.06. God, okay. Intisar, I don't speak French. If you have a question that's in French, I might be able to figure it out based off the math that's happening. And I have used Google Translate to try and help figure it out too. So you're still welcome to try. I have a Discord, you can post a screenshot. I might have to just say that I don't get it though. But I've been able to work my way around doing questions in different languages before. I just can't promise I can always do it. So wait, okay. And Thunder, let's just like back up. So we want the probability of x less than or equal to 4 and do 1 minus that. What do you get for p of x less than or equal to 4? Ugh. 0673. Do you get 1754? Did I do it wrong? You know what? I forgot which number the alligator eats, I guess. I was taking greater than or equal to 4. That's why we're getting the flip of each other. I need less than or equal to 4. 8245 or 8246. Okay. Oh my god. Okay. Figured it out. Brayden, thank you for the follow. Okay. Double Poisson? I don't remember Dan saying that. I wonder, maybe there is a way. Oh, is it? Is it like over a given 2-week period you expect to get so many days with that number of parts? There might be some kind of rationale like that. I haven't done that technique before though. Solving your own band notation problem in math chat. I've never heard of band notation, but no worries, Brayden. Do whatever. Teacher said there were 2 ways to do this. That might be possible too, Thunder. Maybe you could do... Oh, that's kind of intriguing. So, if the probability... Oh my god, okay. You don't have to, like, you know... Well, do I even want to do it on the whiteboard? The more I think about it, the more I think you could double Poisson. Oh my god, Bob, it's ridiculous. Yeah, I'm in way too many, but I'll like, I'd say like 80% of them are related to Daisy, and everything has its own Discord. You get what I did so far? Okay, that's good. Oh, you clipped that, Zach? I'm sorry, but if you don't think about inequality in terms of the alligator eating the bigger one, you know, I don't know if I want to talk to you. It's so intuitive to me to remember it that way. Okay, so yeah, no, we that's completely fine with me, Thunder, because I completely understand if you're just like, you know, you don't want to think anymore, because I've been there. 70 track media related discords. Geez, you're coming up on the cap unless you have Nitro. Fun fact about Poisson, something called few photon regime. Laser filters emit few photons continuously on a Poisson regime and will blindly follow it. Huh. Wow, I will never guess that, Synchrotronica. I think it's 100 servers, Bob. And like, if you have Nitro, it's like 200 or something. 98? You're almost there. As far as I know, it's 100. I don't remember exactly. Okay, so yeah. Theorizing. What I'm wondering, if you were to try and double Poisson this, right now, 60 years old when I learned that 3435 is 3 cubed plus 4. Really? That's super weird. Do you have a chat with the physics man? They poisoned our photons. Okay, you know, let's do green. I don't use green often enough. Okay, so what we start with PO, average of 6 for a given day. Ah, I didn't plan ahead what I was gonna actually write here. Oh, sorry about that. Need some water. I feel like something like just got on my throat. No one say that. That's what she said either. Okay. And so, I think we would start off the problem the same way with we want p of x greater than, strictly greater than 6. That's not a 6, is it? Which we already calculated as 4457. What was the next step now? Wait, I had an idea in my head and now I lost it. I'm actually trying to write things out. Double Poisson. Do you take that to the 12th? Is that where I was going with this? Or the 14th, rather, for 14 days? No. I don't know. I had an idea in my head and then I lost it. Maybe there is a way to double Poisson. I'm onto something? Oh no, Thunder. I feel like I'm half onto something. I'm getting stuck where to go from here though. You need to somehow translate this faulty components per day into a day with at least 6 faulty components. Or I guess... It's gonna bother me. The average number, given a 2-week period, the average number of days with at least 6 faulty components is what we would want to get with our, you know, if we were to call it maybe y. I don't know what would go in the parentheses though. And maybe with this distribution, you can do greater than or equal to 5? And you're home free? But even then, you're not capped at 14. So I'm not sure exactly if that actually works. But that's where I was trying to go with a double Poisson thing. I don't know. I don't know if I'm thinking about it right, though. Cook more? You remember? Oh, God. I don't know, Thunder. This is where I'm... Oh. This feels like there's something valid here. Oh, that should be PO, not P. But I'm kind of lost here, so I don't know. I don't think I'm able to cook more. I'm a lot of gas. Maybe you'll never know. I mean, we could try to look for an example. Google has all the answers, right? I've never asked ChatGPT a question in my life, and I don't think I ever will. Oh, God. Given an corporation gets usually 360 emails in each 6 hours of work. No. I'm not asking ChatGPT this question. I don't trust the word that it says. In 10 minutes, the corporation will get at least 2 emails? That's a normal Poisson. That's only Poisson once, I think. Yeah, he has to scale the time. That's not what I want. Oh, don't download I hate when I click on a Google link and it just downloads something. Like, I feel like that's like a security issue. I think this double Poisson thing is something else. I don't know. Yeah, Thunder, I guess for now I don't have another thought on this. Oh, hey, gosh, Biopiv? I hope that's a little bit closer than what I was saying yesterday, at least. In university, I majored in applied math. It's basically the answer. Oh. Who is this that just posted something in the thing? Right now, I don't really have a real job. I have I'm doing this. It doesn't make very much money, and I'm seeing if I can make a job out of it. But I basically quit my boring office job to try this out. I don't really know what okay. Is bio? Is that close enough? I don't know. Hey, Lele. You did post or there was some follow-up. Oh, that's from Talos, though. Okay. Bio? Okay. I'm glad that I was able to get to the to the bottom of that. Okay, so Talos did post a follow-up to that one question. So let us know if you have anything else about that. I did minor in computer science. Oh wait, what happens to that question that the person just posted? Oh, here it is. So yeah, I minored in computer science, and sorry, Lila, I'm just figuring out what the next question is going to be. I guess we're going to make it this one. So I don't know why it's showing as an older post. Thanks for the follow. So yeah, I minored in computer science, and I like programming, but I get a little bit bored taking on big projects. So I like coding like short things, but if it becomes something kind of massive, I kind of tap out. Oh, that's so weird. Why is that older post 3 minutes ago? I'm not sure the person is here right now, but I can definitely do this. If minus 5x squared is part of fx, differentiation from first principles is an expression for dy by dx. So yeah, y in the function, if it's hard to read, y equals 3x minus 5x squared. So when you differentiate it, you get 3 minus 10x which is what they said. To go by first principles, I get an extra 10x squared from the minus 5x squared and the minus f of x. And Intisar, I see your question over on YouTube. Let me look at this one and at a party there, how well are there more peanut butter cupcakes than strawberry cupcakes? Are you talking about like ratios or proportions? Because I could just say that there's 30 more peanut butter than strawberry, but I don't know if that's what the question is. I know that translation might be a little bit hard. If you want to try posting in the original French, I can try to plug it into a translator too. But I'm not sure. I feel like I'm not answering the right question. I'll copy it over to Twitch chat too. Just in case someone else wants to see it. For this person, differentiated minus 10x plus 3. When I do it by first principles, 10x squared minus f of x formula. Oh, I think first principles is the limit definition. Okay. With first principles. With first principles. Is it does it involve limits? You did that, Intisar? I'm not sure what else the answer would be besides 30. We could try and make like a ratio between the two. Or like say like, you know, there's whatever 5 peanut butter to 2 strawberries. I don't know. I don't think that's the actual answer, but something like that. Does it involve limits? How do you make a limit in LaTeX? LaTeX limit. I'm just going to try and quickly type out the limit underscore x22. Okay. slash lim underscore x slash 2. Wait, no, as h approaches 0. Of slash frac f of x, oops, plus h minus f of x over h. Hopefully that renders okay. Okay, good. That's fine. You'll try it later. All right. I'm sorry, and sorry that I can't help you more. I'm not sure I'm understanding the question right. I'm pretty sure that's what they're referring to. Okay. Oh, perfect. Glad you figured it out. Let me know if I can help with anything else. Gotta go now, but apparently our P for the binomial distribution is wrong. Really? Greater than or equal to 6? No, I think your friend's wrong. Because it says more than 6 faulty components. If it said at least 6, I would agree. Oh, less than or equal to 6. Oh. Well, you would do 1 minus x less than or equal to 6. Was our final answer something big or something small? Okay, no, it's all good, Thunder. Please go. I can think about it more later. Or I mean, let me know if I can help with anything. Okay. What do you think about trig equations? They can be really tricky. If you have a question on a trig equation, I bet that's a good chance I'll be able to work it out. Well, so I got 8246. Do you need help with it, Bio, or is just for fun? Oh, is that who joined? Oh. Welcome in. We could take a look at it just for fun, I guess. Or it's just like, I may just like see if I can get the idea without going through with the work. It was the right answer? Oh, okay. Glad to hear that, Intisar. Huh. So the issue was up here. Oh, ha, I did make a mistake. Do I have a wife? No, I don't. Yeah, no, because it's more than 6, so you do less than or equal to 6, and then you do 1 minus that. All right, let's update the work. Let's verify that the answer is right first, though. You know, maybe it'd be more interested in math if people didn't call them hoes. That's all I'm gonna say. 3937. Hey, Star. I'm doing good. How about you? Married to the math grind? Exactly. That's good to hear, Star. Okay, so 3937 is our new probability is 2. Oh, yeah, I need a decimal there. Nope, that's not a decimal. That's a decimal. What? My browser lost its connection? Oh my god. 3937. Number of trials, 14. Number of successes, X. We want X greater than or equal to 5? Yeah. Which is 7042. Okay. That's right. I messed up that the Poisson part was P X greater than 6 rather than okay. The real calc teacher's last name was Hoa. Oh, really? Do you have guns? I mean, oh, sorry, you're done with math for the semester. That's awesome. Congratulations. I do not have guns. I don't have that much against them, but I don't want to start that argument. And the inequality signs on stage 1. Heart. Well, you know, if you come and visit, there's places where you can do that. I know it's a stereotype, but not every American is super into guns. But it's kind of a contentious topic over here, so I'd rather not. Stir up a fight, I guess. Okay. So I'm just going through Discord and organizing a few things. Okay, I've had a DM on Reddit. We should go and check that. I haven't been on Reddit once, which is great, so that means we had questions from chat, but right now we don't, so let's go and check what that DM is. Oh, please don't be stats related, jeez. Martial arts? I did a little bit as a kid, but nothing like ever seriously. Oh, it is stats! Oh my god. I'm very late to answer this, unfortunately. The New California Republic possession of guns. I mean, it basically is, yeah. I wouldn't be in the Fallout New Vegas universe without a gun. I think they got it. Normal distribution calculator. We can just confirm it. 0, 1, between. Oh, hey, we got 1.9. Oh, no. Wait, what do we say it was? 1.65. Not 65, 1.65. It's very different. Oh my, stop deleting the entire thing. No, I need a minus sign. Don't delete the entire thing, please. Okay. 90111, that's close enough. Montenegro's without looking at a map. I mean, I've definitely heard of it before. It's somewhere bordering the Mediterranean or pretty close to it, I think. That's the best that I got, though, for a guess. Ajax, okay, yeah. Even verify by calculating, by plugging in, plugging it into a calculator. Between minus 1.65 and 1.65, and it'll be close to 90, but not exactly, because of how we rounded the decimals. Okay. Did a little bit of Taekwondo when I was little, bit involved making weird noise and performing some moves. I did Taekwondo as well, and that was my exact experience. You don't really learn to fight. It's more like a dancing, honestly. Okay. Maybe I'll take a quick peek through Reddit for a question, and if not, I'm going to go over to the real analysis stuff that we were doing this morning. You know, the music has been paused for so long, and I just didn't even notice. I was too engrossed in this stats problem, I guess. There we go. Stats engrossed in a slightly different configuration. On the geometry. Oh gosh. I might rather do stats than geometry, I'm being honest. Give up on all plants or all meat? I'd rather give up all meat. I already don't eat too much meat normally. Never give up on meat. I mean, if you're only eating meat, that you just can't survive as a human, I don't think. As far as I know. You do need something else besides meat. Is this a proof that 2 equals 1? Okay, they have to find the mistake. Alright, this might be fun. Only meat and dairy? I mean, if it works for you, I guess. Alright, A equals B, given. Multiply each side by A. I guess that's okay. Bio is 2 based. Subtract each side by B squared. Have we seen this before, Jet? I don't even know. Oh, you can't divide by A minus B. A minus B equals 0. That's the mistake right there. Like, case closed. BBB. What's the rest of the proof like, though, just out of curiosity? Subtract each side by B squared, factor it. Get. Okay, A plus B equals B. Place A with given because of given. Okay. That's a weird sentence, but it works. Okay. The issue is with dividing by A minus B. If A equals B, then A minus B equals 0, and you're not allowed to divide by 0. They do divide by A minus B, right? Yeah, okay, not B minus A. Either way, it's still the same answer, but... Another proof similar to this, but much more obscure. Oh, like the error was a lot more hidden. The polar coordinate. How do you know the polar coordinate is something different from a circle? An ellipse and polar coordinate. That's interesting because you can't. You know the easy. Oh, it's just given. Yeah, I guess. Yeah, I'm sure you could prove it. Did they scan this with like a photocopier? That's what this like. It sounds like photocopy vibes to me. Why do we have the exponential there? How would you work it out? Would you take x equal r cosine theta, y equals r sine theta, and hopefully manipulate it to something that's nice? Do 2 men really get married? Yes, two men can get married if they want to, bio. And I hope you're not going to say something that's too controversial that I wouldn't want in my chat. Um, Proof that pi equals 3. Oh, okay. Hey, Viv. Glad to have you. When you rotate 6 so that if it's upside down, you get 9. This is trivial. 6 plus 180 degrees equals 9. Oh, what's wrong with this proof, Viv? I don't see the issue. Your building's gonna fall. This thing makes sense. Why? Thus, 6 plus 180 degrees equals 9? Oh, upside down. That's why they're... Okay. Yeah, I mean, I don't see the issue here. The universe is dying. Here doesn't really happen, or here doesn't happen, so you can't really mention it happening. Oh, that's fair enough, Bio. I don't know about the issue to really like comment that much, but no, it's a real thing that does happen. Happen if pi became 3, math would get a lot simpler, I think. Women marry women too over here. So there's a whole wide world out there. The universe is non-Euclidean. Oh, for pi becoming 3? Pi being 3 really? I guess that seems like a weird thing could happen in a non-Euclidean universe. Oh yeah, I'm sure that we wouldn't know that at least right now, but something that it's something that's crossed my mind, so I guess I could see. No, you can't. Okay, I'm sorry. I want to talk about math. Like, no, you can't punch women here. I hope you can't punch women anywhere, but I know what happens. Like, if you don't mind, though, I'd rather just talk about math. Like, I don't really want to. You absolutely cannot do that here, and I wouldn't want to go to a place where you can do that. And if you don't mind, let's just keep it to math, because I don't want to... This is a weird train of thought that you're on. All right, Bio, you actually you need to calm it down, dude. All right. Well, I'll see you around then. Where the heck is this? Oh, it's probably in line integrals, isn't it? Have been to Mexico? I have not. I would love to. But I have not been, no. So it doesn't really prove it, but this is basically what I think the person needs. Oh shoot, I got beaten to it. Okay, well, never mind. Let's move on. SPQ, they're just asking why the parameterization of an ellipse is the way that it is. They had these two ellipses, and they were wondering why basically x equals AR cosine phi and y equals BR sine phi. So someone else already answered the question, though. I don't really have a good response, though. I was still trying to like figure it out, and then someone else beat me to it. Go to Kalima, 24 out of 100. Oh, geez. Yeah, I'd rather go to a part that's not bad, I think. So, I don't know. There's already answers, so I don't think I'm going to, like, jump into this. Like, the only response I really had was that it's just a common parameterization that you should know, but other people are answering the question that's more of, like, the why. Which is probably what they're really after. Yeah, that's a nice way. I think that's what at least one of the answers was basically saying. I don't like. I'm not completely satisfied with that because if I was a student taking a test, I probably wouldn't realize that in the moment. But I think that is basically just the answer right there. All right, so I'm not seeing a ton else, or a ton to do on Reddit. So maybe let's go over to the real analysis after long ado. Much ado? What are you're supposed to say? Okay, so I feel comfortable enough with all the stuff up here. And all of this, and all of this. We kind of half did number 5. And I get the intuitive idea that's going on with number 5. I don't feel like I understand the actual mechanics, though. Dude, I kind of suddenly have to pee here. I think I'm going to take a quick break. But when I come back, I think I'm going to try and think a bit more about number 5 and try and understand it. Be right back. Oh, that's all right. Okay. We're back. Okay, so we have this definition of uniformly continuous, which is basically you can choose a delta such that any pair of x comma y you want to choose is always going to be within a given error tolerance. Hey, Obi. And we figured out why it does not work for x squared, because no matter what delta you choose, x squared always blows up to infinity, so you can always just choose a pair that's like very far apart. Did I have that backwards though? No. You can choose a part that's higher up along the parabola, I guess, and get a bigger difference. What's going on with the cube root of x though? I don't know what that graph looks like. I assume it's like root x, but maybe it also goes the other way, almost like arctan. Unless I'm way off base. Oh, yeah, it is like arctan, but it's unbounded. Now, if it's unbounded, well, okay, so I think I'm thinking about this almost like in calculus terms, where the sharpest change in value from the function happens around 0. And the farther out you go from 0, it levels off. So I guess the thing we want to key in on for this function is choosing a delta that will work for this part around 0, and it should definitely work for anything away from 0. That's my kind of thought here. But how does it actually, like, work? Given epsilon equals... Oh, you know what? I should have known what the cube root of x looks like, because it's just the inverse of x cubed. Okay, I don't know why I didn't put that together sooner, but anyway, it's not important. Given an epsilon greater than 0, what does this mean? I feel like I knew what it meant at the time, and now that I'm actually trying to apply it to this other function, I feel like I'm losing the thread. Let me bring up our notes. Okay, so we're gonna down here in the lower left. And so we came to the conclusion that it's like this statement down here, where for any xy pair you want to choose, it has to work for the same delta. Wait. No, it's the second one, where you have to... Sorry, my interpretation was right, just the actual statement I was attaching to wasn't. So this one says that you have to choose a delta for any xy pair. And this is a statement that aligns with how Zach intended the question as far as I know. So I wrote this part with x for growing without bound, but cube root of x also grows without bound. It just does it a lot slower. What if Poisson is just stupid and we never look at it again? The world will be a better place, Dan. Also, Thunder said there's a way that you can do it with two Poissons rather than a Poisson and a binomial. As an alternate way. Like, apparently his teacher said that there's an alternate way to do it with Poisson twice. Yeah, I tried to work it out, but I got a little bit stuck. Actually, I was trying to work it out up on the board. I couldn't figure out what to put in that second y variable, though. But yeah, the consensus that me, Thunder, and I think Stuki all agreed to for how to do the problem is what I typed out in my Discord. If you're interested in like looking at it for yourself, I guess. But it was the same thing with doing Poisson and then doing binomial in 2 stages. Apparently, you can do Poisson as one stage and then Poisson again as second stage. It feels possible, but I couldn't quite work it out. But yeah. Oh no, there's 2 different ways to do it. One of which is binomial, one of which is a second Poisson. You always need that first Poisson, I think. And then the second stage is Poisson or binomial, depending on your taste. It sounds like, but the Thunder couldn't recall it exactly, so. So the way that I did it with binomial Poisson, and then binomial agrees with an answer that Thunder got from a friend. So I'm fairly confident that way is right, but there might be another way. Yeah, sure, Dan. Gosh, frickin' Poisson. Good old Poison and Cauchy, my 2 favorite mathematicians. What's the second derivative of the cube root of x? I should just know that, but I'm too lazy to actually do the power rule twice. Wolfram Alpha know what to do with that? 6x? Oh, no. Cube root of x. What? Can you give it to me in a reasonable form? Take your degree back? Yeah, I hereby revoke your degree. Oh, you have to worry about negative inputs, I guess. Really? Is there an issue with this one not always being valid? Is there a hidden squared in there? Or like square root that I'm not seeing? I don't know. Okay, so I was hoping, maybe I still can make a point. I was hoping to make a point about the second derivative. Well, no. No, that doesn't work at all. Well, no, it does work. So what's happening here is that your second derivative, as x gets very big in the positives or negatives, I guess very, very big or very, I mean, small is, I guess bad because small could be close to 0, but as x goes to positive infinity, it approaches 0, and as x goes to negative infinity, the second derivative approaches 0, which indicates that the curve is like leveling off and approaching a horizontal line. More or less. Not really a horizontal line is a bad way to put it, but I'm just going to say it. Whereas with the other example, x squared double prime, we have a constant function of 2, which certainly does not approach 0, which I was getting messed up on. So that's something where I was thinking like that might be the difference with why x squared does not work, but cube root of x it does work. I can't really explain away why something nasty doesn't happen when it's close to 0, though. Or like why we're still able to bound it for when the function is changing a lot. That's kind of the tangent that I'm on right now. Get it? Because derivatives? Okay. What face? There's no sick of my BS emote. That's true. I need to work on that. Well, actually, wait. I did just kind of add one today. Let me. It's not maybe the exact vibe, but I did just get this one literally right before I started the stream. I uploaded it. Yeah, that email like cracks me up. Bad streamer. Hmm. Zero is less than x minus y is less than delta. Okay, so if we're given, I think I need to plug in some values and just like see if I can make something work here. So if we're given epsilon equals like 0.1, we should be able to name a delta such that there's no pair of x comma y that gives us a difference in the function values greater than 0.1. That's where I'm getting tripped up. There's like a couple of steps in there. Maybe let's try drawing this out on the whiteboard. Wait, I kind of just like draw a graphic function to try and visualize what the epsilon means and what the delta means. Okay, so okay, so we have y equals q root x. And we're just going to arbitrarily say epsilon equals 0.1. And even then, I'm not going to draw things exactly, so I don't really know what the point of that is, but so we want f of x minus, well, do we start with x and y, or do we start with f of x and f of y? We have to choose a delta. Oh, no! I forgot to charge my phone before the stream started. I freaking hate that I always forget to do that. It's literally right as I start to draw something on the whiteboard, too. This is never a problem before, because I wouldn't stream math for, like, as long as I have been the last few weeks. All right. Off to paint we go. Okay, it's encroaching a little bit on paint, but, you know, who cares? All right. At least I can draw straight lines here, you know? That's always a plus. Let's get our same deal. Okay, so y is the cube root of x. Y is the cube root of x. How is the cube root of x? When is the cube root of x? Okay, and so if we have an epsilon, let's say, just for the sake of argument, like 0.1 again, then we can have a very small difference in the x's and y's here, or a very big difference in the x's and y's here to get our difference of 0.1. This is not to scale, but the point is that if we're using our entire 0.1 epsilon space, the closer we are to 0, the smaller the interval on the domain has to be, because the function is changing so much faster closer to 0. Whereas when you go away from 0, the function stops changing as quickly. So you have to get a bigger difference between x and y to get your same 0.1 spacing. Now that's kind of the opposite of what I was hoping would happen, because cube root of x still grows without bound, just very slowly. It's like how do we name a delta here that would work for any 0.1 difference in the height of the function? I feel like, see, I have it reversed, I feel like, because wait, let me get my blanket on. So I'm gonna be staying at my desk because I'm using paint. Okay. Or is there something that I'm maybe not? Oh, there's obviously something that I'm not seeing here. So we can't choose a delta for a given xy pair. We can choose a delta for a given epsilon, though. Sure, Brayden. I can't promise I'll understand it, but if you want to talk about it, I'll give it a shot. Maybe I need to also look at the parabola case. Titration? Yeah, power to a power to power, like 2 to the 2 to the 2 to the 2. Newt's up arrow. Ooh, I think so. Is that because I've definitely seen this before. Does it mean like do you have to do it like does this equal 2 to the 2 to the 2? Oh, the visualization, Zach, you're right. I forgot you mentioned that. Oh, that up arrow notation. Okay, I've seen that too, I think. 3 tetrated to 3. Wait, so is that 3 tetrated 3 times? In pentation, is that 5 times? Or I don't. Hmm. Yeah, the titration I understand generally as like a power to a power to a power. That's about the most that I know about it, but pentation is repeated tetration, so 3 to the 3 to the 3. Interesting, okay. Hmm. I guess I'm not familiar with that, but I guess I'm following. Can you expand out? I don't... Is that different from 3 to the 3 to the 3 to the 3? Whatever, like... 3 to 3 7 trillion times? Oh. Okay, so you could expand it out. You just would take a long time to write it, and you do a very long piece of paper. Wait, real For every real positive number epsilon greater than 0, there's a real positive number delta greater than 0, such that two function values f of x and f of y has a maximum distance delta whenever x and y are within the maximum distance delta. That's at each point x comma f of x on the graph. If we draw a rectangle height slightly less than 2 epsilon and a width slightly less than 2 delta around that point, the graph lies completely within the height of the rectangle. Okay, so the key is that the function can't go out the top or the bottom of the rectangle. It's also hexation, which is repeated pentation. Eventually you get repeating errors. Let's talk about simple band notation. Band notation is a compressed form of the up arrow notation where A equals A, AB equals A to B. ABC is equal to A, CB, where C is how many up arrows there are. Wow. You get crazy high numbers very quick with that, I guess. So like I understand the visualization. I'm still trying to connect it back to the actual words. So delta is something that we get to choose. Mm-hmm. Can have as many rate sections as you want. Wow. You can also calculate, but you could, yeah. That's crazy. I didn't know that representation for numbers like that. Positive real number epsilon greater than 0, positive number delta. Oh wait, is this the? Oh, that's a caption. Okay. 3 to the TP. Fair enough. So then for a function that's not uniformly continuous, there's a positive real number, some greater than 0, such that for every positive real number delta greater than 0, so my question with this is why can't we keep shrinking our delta until we don't go off the top? Because shrinking the delta, surely it wouldn't affect these earlier two boxes. Is the issue that eventually you'd have a delta that's basically equal to 0? As you go further and further up this, like, exponentially increasing graph, or, however it's increasing? Oh, if we shrunk the delta, it would come up through the bottom, I guess. This feels like it's not related to continuity. It feels like it's related to just the rate of change. Like I think the names are part of having an issue with which like why is this related to continuity? Hmm. Maybe I might need to think about this more because I feel like I'm not like I think I get the idea, but I don't get why it works for certain types of functions and not others still. PhD, I see electric control boxes with the wires between them. They do look like that. Ugh. Yeah, it feels like the like these are the circuit breakers or whatever. Um, it's for the something we were talking about in the real analysis today. Zach linked this, and I think I just need to like look at it a few times over a period of a few days, and hopefully it'll sink in better. Do they explain why it's called uniform continuity? Oh, well, what's this? Epsilon equals 0.5, delta equals 0.2. Has the center of the blue window with real height 2 epsilon and real width 2 delta. Moves over the graph. F of x equals 1 over x in the direction of x equals 0. There comes a point, the top or bottom, right? It's like right now it's not uniformly continuous, I guess. Be infinitesimally small. Okay. Okay, that answers a part of my question. You remember watching a good vid about pointwise versus uniform convergence? You don't know about continuity? Oh, okay. I don't think if we have the pointwise convergence, it's not by name. But definitely, if we do, I'd be interested in looking at that. Stronger condition. So uniform continuity is a stronger condition than regular continuity. Oh yeah, let me save that. That URL has a lol in the end, which kind of makes me laugh. Yeah, it's like get it opened. Pause. Please pause. Thank you. Just so I can like remember to save the link for later. Thank you for that. If their slope becomes unbounded on an infinite domain, so it is connected to tangent lines. This is an actual helpful like Wikipedia article. I'm kind of surprised. it does go into things like, you know, Lipschitz map that I have no idea what they mean, but the points before that actually make sense to me. So I still need to let this sink in, but seeing this part up top did help me out too. Okay, let me... I think I need to drop uniform continuity for now, though, just so I can not go too crazy. That's actually the end of the prompts that we had for today, so I kind of want to revisit some ones from Tuesday, if I can find them. Hey, bring it here. There. So, I'm going to skip 4 and 5, but I talked about them a little bit yesterday. Okay, but I'm kind of good without talking about them for now. So there's a bunch of limit properties that we could prove. I did watch Penn Center go through all these last night. I did this one on my own, actually the addition one, as part of a different proof. Man, I feel like they're going to be weird. I kind of want to see prove or disprove a function f is... I kind of want... Okay, what about 7? Limit as x approaches c of f of x equals f of limit as x approaches c of f of x. What the heck? This one, I have no idea if it's true or false. Maybe let's do some exploration with it. This could be fun. That does not look good. Just keep it that same size, I guess. Get my phone turned back on so I can get the whiteboard cam going again. Okay, so let's just take a standard limit as x approaches 2 of x squared is equal to 4. I hope we're on board with that. I don't need to do an epsilon delta proof. I mean, technically that was a previous prompt, but well, I should it'd be a squared on the outside like that if f of x equals x squared. Did I just disprove it though? Because surely 4 squared is 16 and 4 doesn't equal 16? Am I missing something? Is this supposed to be the limit of f of x? Is it a typo? Like it should be... Because otherwise this doesn't... That doesn't seem true. Like this is a... I don't know how you would do this, but that's what I thought the question was going to be like. Let me get my phone some more time to charge before I put the cam back up. boy. Okay, well, I didn't even see the continuous part, Jeff. Function f is continuous, x equals c. Yeah, it has to exist if it's continuous. If it's not defined at x equals c, then it's not continuous. But I think my example is continuous, so I don't see. I feel like there's a typo here. So maybe I should look for a different one. Ask Zach about this one later. So we do have number 8. Those controversial sessions yet? Yeah. Don't get Bob started on whether this is separated or continuous. It's been a matter of great debate. Or separated or connected. Yeah. You would think, Jeff, with the definitions that we've been provided, it's kind of a gray area. I can bring those up too. So the argument is basically, you would think that this is separated because there's literally a separation inside of between 2 and 3. But the definition of separated that we have only provides for open intervals, and good luck naming an open interval that will, like, I guess, minimally capture, to make up my own terminology, this, or I guess 2 open intervals. And so since the definition of connected is just not separated, you can apparently make an argument that it is connected. Okay, and that's what Zach was saying. I don't know. I don't really have a dog in the fight. I don't care which one is true. Yeah, I think that's what Zach was saying. At least, I don't remember if it was actually on stream, because there's a little bit of debate was happening a little bit before class started this morning. And I think Zach was making that point. I don't really know enough about it either way, though. Is this A prime and B prime? Yeah, I mean, this is one where I couldn't tell you guys either way. I'm not the authoritative person here. So I still trying to understand what SPQ is saying, but If you haven't misunderstood, if you're not sure, Jeff, I'm not the person who can answer your question, I guess. That's what I'm trying to say. So I don't know who's right in the debate. Zach is saying this is separated and the definition is fine as it's written. Bob has been saying that it should be adjusted, but and that as written, the set is connected, but I don't actually know. um, but yeah, that's basically the most heated debate that's been happening. I want us to look at number 8 over here, though. So the following statement is false. All polynomials f of x of prime degree have an x belongs to R, where f of x is equal to 0. How could you minimally change the statement to make it true? Well, first let's understand why this is false. So the problem is, oh yeah, I think Bob was being an instigator over there. I missed section 2 on Tuesday though because my electricity was still out. So actually, I kind of cheated on this one. Penn Center looked at this one on stream, and he pointed out that the counter example here is f of x equals x squared, because of course 2 is a prime number, and this has a 0 at x equals 0. It wouldn't work for any other prime number, or it would work for, well, yeah, it's fine for any other prime number because you could actually make an even more general statement because all prime number, I think the important thing is that it's odd. Yes. So it is true for primes greater than 2 because primes also happen to be odd numbers, and an odd degree polynomial, at some point, one side has to go up and the other side has to go down to infinity, or vice, or, you know, it could be like this, or it could be like that, and by the nature of the two sides going to opposite directions, you have to cross over the 0 point somewhere. And an even degree polynomial, you could have, no matter how high the degree is, you could have, you know, just like going up and never quite touching the x-axis, and same with negatives. So we want to change the statement, minimally change the statement to make it true. Well, I guess you have two options. I feel like the better statement, or the better adjustment, is to say odd. Well, 1 is odd, and that also, okay, yeah. It works for x equals 1. You do have a second option, which is to specify x greater than 2. Or sorry, degree is greater than 2. But I feel like odd is a cooler statement. How can we prove this, though? Using the terms as we've learned in the class. So we haven't really done limits to infinity. show the dominance of the highest term. That is probably a good strategy. Yeah. I think I like that, Jeff. Oh, yeah, and okay, the factoring out thing is a good way to actually show that. So, if we somehow do induction here, I don't see how peach tea. Like maybe for a given degree, you could show that like f of x is less than or equal to f of x, or I mean even strictly. Actually, you would want to do strictly. Do something like that and just show that it's like always increasing after a certain x. That's the only way I could think to possibly induct, but I think I like Jeff's approach a bit more. So consider a polynomial of odd degree f of x equals ax, and now how should we express our degrees here? 2n plus 1 plus b x 2n plus c x 2n minus 1 plus, so you get the idea with the pattern. These are bad naming for the constants, right? We should do a0, a1. And then how does this work at the end? It's gonna end with, I guess, a sub 2n x plus a sub 2n plus 1. Where n, let's say n belongs to natural numbers. I don't remember, are we counting from 0? I can never remember in this class. Let me see if I can find it. We are not counting natural numbers from 0. Okay. Should I say non-negative integer? I could do... Sure. Whole number? Not 0? Well, I don't want negatives. Yeah. Okay, so f of x is equal to, I guess we're going to do our factoring. Wait, that's not how you factor. Just the opposite of how you factor. Well, no, that is how you factor. It's just not what I wanted to factor. It's supposed to be a 0, by the way. I feel like it's not a 0. That's just x, right? If you have x to the 2n, wait, it's I can't do exponent rules right now. It'll be x squared. Okay, okay. Thank you, Jeff. A so 2n, and here's where the n's get back involved again. Oh no. Okay, well, the nice thing about paint over a whiteboard is that you can just shift things around. Oh god. Damn, makes it look so easy though. I have just barely enough room. Oh, okay, that's good enough. Think you was wrong. This is go nowhere. Oh god, really? I mean, it might need. I don't know. I don't know if we have the background to make this claim, but I thought we were going to say for large values of x, this becomes approximated by. So this part, I don't know, we haven't really done this in class before, which is why it might be a little bit sketchy. I thought that's where we were kind of going with this. Yeah, Jeff, that's a good point. I don't, have we done something that's like it though, I wonder? I'm trying to think back to our previous classes because we are still going to infinity. Like, you know, like this unbounded limit. I don't think we've done it in class. We're going to divide f by the absolute value of x to the 2n plus 1. Is that more or less what we've just done, though? X less than negative n implies p of x less than 0. I guess we have used the idea that like 1 over n approaches 0, though, as a sequence. Some squiggly equal sign, and it scares you. Yeah, because I'm using things that I've seen outside of the class and I'm applying them here. I guess maybe this might be, it's a little hand-wavy to not justify this, but maybe we can just roll with it. We haven't explicitly done a limit as x goes to infinity, but we have used that idea of like the long-term behavior of a function, I guess. I don't see a different way to do it, at least. So we can always... keep this going. I might get yelled at by Zach, though. Um, if we can, just like the proof isn't that much longer after this part. Sounds good, Jeff. Then f of x is greater than 0 for large positive x. If a sub, dude, this is such sloppy mouse writing, but it's all good. Less than 0 for large. Should we actually, we should keep the a sub 0 case. We should see a sub 0 through to the end. Before we move to a sub 0 less than 1. Comma. And f of x less than 0 for large negative x. Is it still large? The absolute value is large, I guess. I don't know. I'm not going to be too fussy about that, I guess. Because small to me implies close to 0, so I'm going to stick with this phrasing, I guess. What point am I making? Okay, since polynomials are continuous, I could just use the typing tool for this. That'd make it a lot easier, but too late. I'm already this deep in, so I'm not going to change my ways now. I don't know if we've proven that polynomials are continuous. I'm just going to say that they are, though. Let's see Zach try and stop me. Continuous. And we actually just proved the I intermediate value theorem today, so I don't feel ashamed in using it now. Even though this prompt is from before we proved it, I'm going to use it. Nay. There you are. I knew I'd get yelled at some point, because I feel like I'm breaking all the rules right now, but like, I don't know. This is how I would think to do it. You want to use it? All right. Well, oh, I mean, the thing I think that you might have more of an issue with is this whole thing here, but just don't look too hard at it. Or some x. Is that all that needs to be said for a greater than 0? Technically, I guess we have to address a equals 0, but I'm gonna be like, what the heck are you doing? A less than 0 is gonna repeat this, but just be reflected. All right, let's go with this. If a sub 0 less than 0, then the argument can be, it's not how you make an E, is it? Oh God. repeated. Dude, okay, this is horrible. I'm using the typing tool. Can be repeated. How should I phrase this? With learn LaTeX. As soon as I get LaTeX and Paint. Well, I guess I should just get a LaTeX editor, honestly, for stuff like this. My phone's probably charged if I get the whiteboard back up and go back to writing by hand. I would need to set that up though. Actually, okay, fine. Let me instead of doing 20 things at the same time, let's just focus on finishing this proof and then I'll do it. The argument can be repeated with values for f of x reversed. I'm just going to leave it at that. If a sub 0 equals 0, WTF are you doing? No. Then repeat the argument with a sub 1, basically. Everything versus a web browser solution. Yeah, I think I might want like an actual program on my computer. Because I've tried to use Overleaf before. I don't remember why I was getting confused by it though. It was probably something that I was doing. Typing in LaTeX is a joyful experience. All right, I think that gets the Dawn seal of approval for a proof, which is not a very high accolade, but it is one nonetheless. In fact, as official certification, it gets a gold star. And it's awarded by me, so you know it's kind of rigged, but. Let me get the whiteboard cam back up. Why? Oh no, you're not weird. Okay. Get the phone on the charger. Okay. Oh no. Okay. Let's see how that looks. Stuff is allowed on my own channel. I'll do it during class if I have to. Okay, I don't want to make it on like motion sick here, but this camera needs adjustments. Let me, or you know, I hate having the shaky cam actually show up. Okay, how's that? Ugh, I hate it. Oh no, I've gone too far the other way now. Okay, I'm gonna call that good. Oh god, I still hate it. It's fine. Okay. No, I can't even deal with having a star at the end of a proof. That feels a little too like a little too bad. Oh, Zach, actually, on question set 7, was there a typo? Like, is this supposed to be the thing that I wrote off here to the right? And if you're not, if you have to leave, it's completely fine, but it was okay. No worries. So I mean, let's go and try that then, because I kind of like. Oh wait, so I wasn't interpreting right. So it should be limit as x approaches c. of x equals f of x like this? Is this a one-line proof where, I mean, if f is continuous, f of c? Oops, that's not, I forgot the middle part there. Or I'm still not interpreting right. I can just move on to a different question, but I'm also confused by if I'm getting the intent right here. So sorry, I don't like bother you when I'm sure you're doing like other things too, but I'll just put a pin in this one for now. Because there's another one, even in and out. Oh, okay. Quasi-lurking. Yeah, no, I just don't want to like ask for your opinion like too much when I'm sure you're doing other things at the same time. So, and oh yeah, shoot. Let me bring up the actual thing. So the only other one from Tuesday. Well, I mean, I kind of skipped over 6, but and 4 and 5. But let's look at 9. Just see what it says. An ultimate definition of compactness of a set is used. Every open cover of a set has a finite subcover. Ooh. Okay. This one I think is actually going to be helpful to do in paint. So let's I'm not even going to bother saving this. I have the VOD if I really want to look back at it, but I hate how I formatted that. Okay. Where the heck? I need to get screenshots here. Okay. So we have that. Really? Let's look at what you linked, PhD. The next time I'll be live on YouTube is Saturday. Nearly 4 hours ago, whatever that is in your time zone. My normal stream days are Tuesday, Thursday, and Saturday at the same time. I missed Tuesdays and I streamed on Wednesday instead, but that was like a one-off thing. Okay, so this is for a composite function. That's the word. That's what I thought the intent of the other one was, but is this? I mean, because it looks like a normal e to the x graph, but if it's e to the 1 over x, shouldn't it look different? I know they're using n, but in a sequence, but I'm kind of curious with a continuous function. What? Can do some improvements for f of g of x. Oh, wait. You do the normal exponential graph because you're taking the limit inside, I think? Yeah, I think you're using the normal one because you take the limit inside. Okay. That's why you're okay to just use the normal e to the x graph. You know, Zach, that would actually be a good idea to try that proof. I don't know if I'll be able to do it, but we could try and look at it. Oh yeah, I agree. We should get one here. That's just the representation of it that was throwing me off, I guess. Okay, you know what? I kind of want to try that f of g of x proof now. Limit, yeah, okay, yeah, it does make sense. We have to specify continuity of e to the x. Oh, I mean, wait, we are doing n to infinity, but then we do 1 over n. So I guess, do we need e to the x at infinity? I might be misunderstanding where you're going with this, but I'm definitely intrigued by the f of g of x problem. Because that one, I wasn't even on the sheet. I don't imagine I'll be able to do it, but I kind of want to like take a stab at it. Let's see if I can figure out some trick. Becomes 0. Oh, that's what you mean, Obi. I see now. It was on the sheet? 12.6? Really? Oh, wait. Today's. Oh, backtrack to a previous. Oh, conjecture of your own. That's what it is. Okay, I see. Prove. F and G. Limit as x goes to c of f of g of x is equal to f of limit as x goes to c of g of x. All right. Let's see what's going on with this. If we I hate the way that x looks. I guess maybe let's just start playing around with the right-hand side because that looks more reasonable for something that we can potentially work with. Well, even before we look at the right side, let's just look at the inside limit. Limit as x goes to c of g of x is equal to g of c by continuity. Is this actually not that bad? Well, no. We still have to show for the left side that's going to be the same. Of g of x is equal to f of c. Continuity makes it too easy. Well, let me do baby steps here, Jeff. It might be too easy for you. It's not too easy for me. What I want to do now is I guess we go to the left-hand side, but what can we do with that? Well, I mean, I kind of want to say something like irrespective of whatever's inside of f. I mean, maybe it is too easy. Maybe you can make a pretty simple statement here. F of g of x. This should... Like, I feel like by continuity, you can say the same thing. And then we've proven it. But that feels a little hand-wavy, I guess. Like that, I just... Like, it's continuity... It wouldn't be f of c, I guess, you're right, but... Limit h of x equals c. Choose two values of h of x wisely. I guess I don't know where you're going with that, Jeff. I don't know where I'm going either, to be fair. If it's continuous... Oh, wait, that's what f of g of c is. Never mind. Oh my, wait, maybe this is like when I was making it. Oh my god. That's what you meant with f, you mean f of g of c. And then this really is just... Well, okay. We can't use continuity for this one unless we know that f of g of x is continuous. That's a question that we need to answer before I can do what I want to do and say f of g of c. Okay. Well, I feel like I've proven that yet. Or I feel like this needs justification. But like, this is the goal that I want to be able to write, but we need to say that the composition of two continuous functions is also continuous. That feels like something we can't just say. F over g where 0 hits an asymptote. We're dealing only with continuous functions. We're kind of taking... Oh, who's that? Bobby Katri, thank you for the follow. We're given that they're continuous, so either we don't have a rational function, or if we do have a rational function, any discontinuities are removed from the domain. How do we go about showing the composition of two continuous functions is also continuous? I think that's the only piece of the proof that I'm missing now. Well, we're not talking about dividing f and g, we're just composing them. F equals 1, g equals x. No, I only care about the, like, f of g. I don't care about f over g. So even if... Okay, Jeff. Trying the definition of continuous. All right. Well, let me bring up the full definition. I remember, like, the main point of it, but where was it? Okay. Let me just bring it up, actually. So, for a specific point would be best. Was that the one that we were doing today? No, wait, that's uniform continuity. So actually, I tried saying that exact function is discontinuous, Jeff, but I think 0 is removed from the domain of f of x. So when you compose f and g, 0 is still removed from that domain. Or I guess you mean you expect to get 1. I think you just never consider 0, though. Be my rationale. Did we do a different continuous? But I think in both plus and minus infinity. Oh, okay, yeah. Oh wait, no, that's... Is this just continuity at a point? I guess this is for all k in the domain. I don't know if we have... I don't remember a different continuity definition, though, so... Oh, wait. Oh, well, single points are always continuous. Do we only care about it at x equals c? And Jeff, I think we're getting mixed up with composition and multiplication. Because if you compose f of g, that's still 1 over x. And if you do g of f, that's still 1 over x. I was multiplying them in my head and getting 1, but whatever I was saying, I was misinterpreting. I was forgetting about composition, or I was thinking it's multiplication. I don't know. So, consider the domain a single point. Well, single points are always continuous for the sake of our class. But the limit, we need to worry about things around that point. Focus on continuity at a point. You can allow for more than one. If the domain is a singleton, you're good and you consider it continuous. Focus on continuity at a point. I guess... The question I should be asking, is it continuous at C? Well, we know f of x is continuous at C, and g of x is continuous at C. Oh. Is that it? So it has a defined value. F of g, or f of x, is continuous. So f of g of c, or f... I don't know, I could have just said this last statement in a vacuum, though, because it's just a single point. Wait, you know nothing about the continuity of f at c? Oh, dang. AFK? Okay. All right, let's back up. I mean, maybe I shouldn't have given myself that f is also continuous. I wonder if I gave myself... g of x is continuous. So limit sx goes to... I mean, I already wrote this up top, but... Hey, underscore play. This is, So my normal kind of shtick is I take math questions either from people in chat or I look for them out on the internet. But when things are slow, like now, I go and study real analysis. And I've been working through some kind of prompts. Well, actually, this is a prompt that I invented, but you need to revise your relations and functions. Hey, Bob, yeah. And so Ethan2i Pi, who was just typing in chat, is doing this live real analysis class on Twitch that I've been taking. And I was basically doing some studying for that. And so the problem that I kind of gave myself that wasn't even actually like assigned is trying to prove the limit of two continuous composed... If f and g are continuous, then proving that the limit, you can basically pull the limit inside the composition. I'm getting a little bit tripped up on a part of the proof. But that's the goal, at least. So yeah, welcome into both you and Bavia. I'm an analysis noob. My background is just a... I have a major in applied math, a minor in computer science, just like a bachelor level. And I always avoided real analysis or any type of proof class because they sounded hard, but a low pressure, like ungraded environment to learn real analysis in has been very nice. Yeah, it's kind of what I've been doing. The first like 2 hours of the stream were me like just answering questions from people in chat, and then when those dried up, I switched over to this. And so I found that the right side of this equality is pretty easy to just calculate as f of g of c if we're given that f and g are continuous here. Well, even though we're not using the continuity of f in this statement, we only use continuity of g. Continuity, oh, that's a good question, underscore. Let me bring it up. The definition that we're working with is actually this right here. And so I've been trying to puzzle out if f and g are continuous, then is f of g of x continuous? And if I can prove that that's true, the proof becomes pretty easy. But trying to show that piece of it, I've been struggling with. Am I mixing up k's and c's? No, I've just been using c. The definition uses k, but it's fine. And actually, since there's two new faces, I don't mean just like advertise to you guys the first time you come and chat, but there's a bunch of great math streamers out there on Twitch that I like to give like a shout out to when I see some new people pop in. So if you're interested in math streams in general, there's a good list of them to get you started. And of course, you're not obligated to do anything, but I'd like to throw out the shout outs. So what's going on with you think I need uniform continuity here? Really? Well, how do we know that f is continuous at g of c, I guess? That's where I don't know where to bring this. I don't know like how to get to that. And Jeff, with your example with 1 over x and x, like you just don't consider the limit as x goes to 0. It's just not defined, and we remove it from the domain. Yeah, I think that is true, underscore. It's just like I feel like we need to prove it. Um, f of x equals g of x equals 1 over x. Well, when you compose those, you get just x. Oh, okay. When as x goes to c, it's just a notation. I would think that we might need to go break out our epsilons and deltas, but I have no idea how you would get to like you can't really take f of epsilon. That's not really fair, I don't think. Hmm. Can you limit what delta you need given an epsilon for g? If it's continuous, then yeah. Only talking about g. SPQ says g is continuous at FSC. If and only if for all open neighborhood U. Gosh. Every point in the domain. I don't know. So choice in your own notation. G is continuous at f of c. If and only if for all open neighborhood U of G of f of c, there exists a V open neighborhood of f of c. Oh, that is the topological definition. We actually did learn that too, I think. I only half understand. Like I wouldn't give myself half understanding though. Where did we do that? Yeah, I'm not good with It's a number 10. So I mean it's technically on the table to be used, but oh god. I can't say that I am good enough with it to actually use it. So it's technically there, but I'd rather not if I can help it. Oh god. Hmm. I don't know. I might just have to put a pin in this for now because I'm just not sure where to take it now. Yeah. Yeah. See, I can say it from memory. For all epsilon greater than 0, there exists a delta greater than 0. Oops. I might be forgetting a part of it, but I think it's like nearly the same. But you have f of c here instead of a limit here. I think that's right. It looks sloppy though. Um, is it like a change of variables, like x equals g of c or something? I don't know where you go with this though either. I was like trying to imagine some kind of way to manipulate that, but if you take like, or if you start with g and you take the f function of each side, that just gets completely messy. Hmm. So yeah, I still don't really know what you do with this, but I'll keep it up on the board if someone puts an idea in. Wait, what else should I do? For you want this property for f of g in the last inequality, but the idea is to use constantly of f and g in the correct order. So I know we want to reach the statement at some point f of g of x minus f of g of c is less than epsilon. But how do we possibly do that? Because like I don't see like what kind of something in terms of like algebraic manipulations with, and I just don't see like what the heck you actually do there. No worries, underscore. Hmm. You just look around in the notes. I feel like we did the other version of continuity. I definitely don't know what's happening there, SPQ. I'm trying to understand it. Yeah. It's hard to I can see you're taking. I don't know why you're using delta 1 and delta 2 for f of c. I assume there's a reason, and then for g of f of c. Actually, I only half see what's happening. Even then half is being generous. Yeah, and that looks terrible. Underscore, I guess. Like, I don't know. I don't know how you possibly do that. Given an epsilon for g and a point f of c, so you find a corresponding delta for g. I'm Googling. Is this saying the same thing or is this different? If you're getting tripped up, but we have different variables here. I think it's the same thing though. They use the capital delta? Oh god. I guess that is more in line with how I would see delta used in physics. It still feels wrong though. eta is being used for this. Doesn't, wait. Oh, no, no, yeah, okay. This is where we're choosing the delta that works, I guess, for both of the functions individually. Why is this hence? Oh, wait. Okay. Wait. Wait, so is this proof real or not? If there's a counterexample, they... Did I bite off more than I can chew here? Wait. How do we know if it's continuous at g of a? Oh, we're just given that. So maybe I framed my own question poorly and I should have given myself that information. Epsilon equals delta sub 1? Oh. Funny how that works. Okay. I guess. This is a good find, SPQ. Thank you for finding it. I feel like I maybe framed my own question poorly because I didn't know where it was going to go. I'm getting my blanket back on. Okay, well, at least I don't feel bad about getting stuck. But all right. I think I'm gonna look at this more like later. Maybe I kind of want to like see if there's a homework question that I can actually do. Because I'm getting a little like real analysis out. Yeah, I mean, I'd say that f is generally continuous, thinking that'd be fine, but I don't know. I don't think that's true. Wait, the premise is that A equals B. Okay, so this is a fake proof that I had replied to earlier that concludes that 2 equals 1. They start from the point that A equals B, and they do a whole bunch of algebra, like algebra to it, and they make you spot the invalid step. And the invalid step that I found is that you can't divide by A minus B because A equals B and you're dividing by 0. I normally agree. But the premise of the question is that A equals B. But the first line of the proof is okay. Even the person already deleted their post, so there's not much point in replying, but I'll still reply. Yeah, I mean, it sounds like it's one of those things where it's simpler with the knowledge that you have, because you know way more about this at SPQ, but I guess with the tools that I have to do it in an efficient way, or maybe I have to use the tools that I've been given or that I actually have. So, which I guess we have been given those, but I'm not good enough with them, I guess. So to be honest, a few years ago I was puzzled with the whole epsilon delta thing. Yeah, underscore. Like it's not the first time that I've been shown epsilon delta. I mean, even like limits, but they've been a pretty huge challenge for me trying to dive deep into them for this class. Even then, I'm sure it's just like scratching, or it's probably not even a deep dive that we've done yet. I'm sure you can go even deeper, but it's probably the thing that I'm weakest on so far still. Oh my god, please no more stats. Might go over to the math Discord. Okay, let's go over to the math Discord, I think. Dude, frickin' Windows. Okay. Alright, so is there anything in here that we can help with? Someone else is already working on this. That one's done, just not cleaned up yet. It's about to be done. That one's closed. Oh, okay, we got a good... Oh my god, look at how many questions there are. Okay. Hopefully we can find something here. Okay, here's some... Oh no, it has... It's like you better get to work. Was there a work integral? I didn't even see that. Wait. Are you talking about continuity here? Oh my god. It's haunting me. Oh wait. No, oh, why are they bringing up epsilon and delta? Or not epsilon delta, why are they bringing up like this? I guess, okay, no, it makes sense. Putting the questions? Oh yeah. What is this? All right. Either way, it's being worked on. Yeah. Oh, yeah. There's like a huge list of questions. I mean, honestly, a lot of them they seem like they're not getting cleaned up. Consume pizza with a fork so as to not dirty the hands. Like, not even a knife, you just have a fork? That seems that's a challenge right there. Oh no. I don't know. As soon as something's congruent to something mod something, I don't know. I learned it once and I forgot it. Modular arithmetic, I think it's called. This is linear algebra. It sure is. It's all good. Underscore. That's funny because we've hinted at that. Because I remember when Zachary, e to the 2i pi first introduced the epsilon delta limit as part of the real analysis class. That kind of topic of each of the input sequences converging to the input value and the output sequence converging to the output value as being related kind of came up. We didn't I didn't know that actual name like that as well though. I don't know how to approach this question either. I've done ones like this before. I would guess that you just get any two perpendicular vectors you want that have non-zero entries and find whatever the third one should be. I mean, they don't have to be perpendicular vectors, just as long as they go in different directions. Okay, let's see if I can puzzle this one out. My linear algebra is really weak, but I might be able to figure it out. Because I can see the equation that I think we need to set up if we just arbitrarily pick a few things. And I think the intent of the question is you just arbitrarily pick a few of these vectors, well, two of them. Wait, okay, blanket's coming back off so I can move around. Spray this thing down. Okay. So we want our given vector is 3, 5, -2. The 3 is kind of cut off, but it looks like a 3. And we want to write it as a linear combination. Jeez, I messed up the thing a bit. B1, B2, B3. So I'm thinking that we can just choose a B1 and B2 that are whatever we want. Say 1, 1, 1. As long, well, not whatever we want, but no zeros, and they can't be scalar multiples of each other. So let's say 1 minus 1, 1. And I'm trying to think what these look like in 3 dimensions. I think they're going to be perpendicular even, which isn't, you don't need them to be, but I don't think there's a reason why they can't. Oh wait, so should we even... We can do it in whatever base we want though, can't we? Because any base that spans R3 should be fine. So we could like... I was thinking we would solve for B3, but the C's kind of threw a wrench in that plan. Do we just choose all 3 of them and then figure out what the C's should be after? So we could... I feel like we could say... that... And are we fine? Are these linearly independent? Let me make Wolfram do it for me, because I don't trust myself. I've been doing so much linear algebra recently, and I'm really not good at it, so... Oh, I guess that would really solve it. Their sum is just V? Oh, that'd take a lot less work, wouldn't it? As long as you know that they're linearly dependent. If the determinant is 4... Oh god, that does mean they're... If the determinant is 0, it means they're dependent, right? Or no, we look at the reduced. Does it give me the reduced row echelon form? Come on. You know you want to. I'm sure one of these things tells me determinant is equal to 0. Okay. Thank you for reminding me that underscore. Hey, Rishi, determinants just for everything to start in the morning. Not for me. But there's someone who's asking about linear algebra, so I always try and stretch to answer it. So honestly, SPQ, I think you have the best idea though. That saves the most work. You don't have to bother. Let's verify that the thing that you said is independent. I think I got you right. Yeah. Determinant is not 0. Okay. If you have n vectors, each having n coordinates. Okay, for a square. Square matrix, I guess. Okay. I mean, honestly, SPQ, that's a smart way to go about it. So it's 3, 5, -2. So yeah, the top 3, 5, -2. Okay, yeah. I like that. You know what? I like that so much, it's a save. To make the work easier, Rishi, do you normally stream this time of day? So My schedule for the math streams that I do both on Twitch and YouTube, my schedule is it's down in the description, but it's Tuesday, Thursday, Saturday, starting nearly 5 hours ago from now. I don't always stream it for this long, but it's at 1 p.m. Pacific time. And I'll pretty much always do it for at least 2 hours. So sometimes you go a lot longer like I do today. So I guess this time of day, not always, but I sometimes do. I don't consistently stream math for this long. We can take our constants to all be 1, take b sub 1 equal to 1, 1, 1, then make b sub 2 and b sub 3 whatever they have to be to make the addition work. Pull up on all-nighters? All right, awesome. What kind of class are you in, Rishi? Unless you're just here to hang out, which is completely fine too. Oh shoot, how do we do vectors in LaTeX? I feel like I'm not really explaining it right. Does the cheat sheet tell me? Ah, it doesn't. Usually do, does LaTeX do normal parentheses as a vector, or you just like, even if it's in LaTeX, you just do them in parentheses and they don't go vertical? Grade. Oh, okay, Rishi, sounds good. For the math part, I can help. Chemistry, I don't really know that much about. They look like in normal text if you write. Oh, okay. I think I'll just give the text explanation and hopefully this person gets it. We have 3, 5, minus 2. If you're not able to catch me live, Rishi, I do have a Discord where you can post questions as well. I'll go back to you either offline or on stream. Plus, how do I say, like, b sub 2 sub 1? that feels kind of stupid. I'll do ABC. I mean, I'll do D, E, F plus G, H, I. I think I have my alphabet right. You just have to choose values that aren't 0 and give independent vectors. Okay, let's see how far that gets them. What's happening here? I know what I'm doing wrong anymore. Isn't change velocity just v of t sub 1 minus v of v t sub 2 minus v t sub 1? Let u be w be 3 orders of r3. Let's assume u and v are not scalar multiples. Neither are u and w, neither are v and w. The answer to that, not necessarily, because if u plus v equals w, they're dependent. It's not just them being scalar multiples directly of each other. You can have like combinations of them. One might say a linear combination. I think. What's the actual question here? What is the change in velocity during the interval from 8.75 seconds to 15.5 seconds? Didn't fall for it? All right, awesome. I'm glad I passed the test there. 8.75. Oh God. 6, 7, 8. Oh, well, okay, you don't need to delete those things. So it goes from positive 5, 15.5 to negative, oh God, 8? So I would think the change is 13. Well, they got the, okay, let me make this a bit bigger because I want to look at the previous question too and see if my logic checks out. Because it looks like part B is the same type of question. So they go from 1.5 to 8.75. So 1.5 is right here, positive 5, 8.75. Wait, what's the scale? Oh. I don't know why there's... I guess it's acceleration. I don't know why it's a of m, but there's no closing parentheses. I don't know why a is a function of m and not t, but... Maybe this is acceleration. Instantaneous acceleration time 15.5 seconds. I expect to see negative 8 over here. Okay, yeah. So this is acceleration. So the velocity, we have to integrate and find some areas. So the velocity at t equals 1.5 is 1.5 times 5. 7.5. And then, well, do you have to even worry about that? Do you just do, no, for change, you don't even need to worry about what it was before. We take from 1.5, t equals 1.5, up to t equals 10, which is 8.5, times the height of 5. Uh, 8.5 times 5. This is a positive area. What's that? Oh yeah, get rid of that. We have 0 area, so we don't have to worry about it. And then we go from 14 up to 15.5. So that's a width of a rectangle of 1. And we're doing minus because now we're in negative area. Let me put that over there. And then the height is negative 8. Well, okay, you know, if we're going to be really, let's do plus and then times negative 8, you know. 30.5. Let's... I did the wrong question. I was looking at part B for the first part, and I was looking at part C for the second part. Oops. Change velocity. Okay, so I mean, as long as we're here, let's verify part B. From 1.5 to 8.75. So that's 7.25. And it's just times 5 because they're in the same rectangle. 36.25. Okay, we're on the right path. Sounds like me during tests. Yeah. No, I do not claim to be a genius or do every problem right on the first try. Okay, so now let's actually do what part C is asking, go from 8.75 up to 15.5. So from 8.75 up to 10, we have a width of 1.25 and a height of positive 5. We have a height of 0, so who cares? And then from 14, we go out to 15.5, which that's width 1.5, times the height, which is negative 8. Minus 5.75. So we have decelerated. Well, actually, that makes sense. Because it's both a longer time period and a bigger negative acceleration. So we'd expect to have a negative overall value here. Okay. Wait. Wait. Change is final minus beginning. I was just adding them. This is final. Oh my god. Why did it work out okay on the first one then, or on part B? Because it's all part of the same... Oh. Wait, okay. I I think I I wonder if this person's actually in calculus-based physics or if they're taught to do it a specific way. Because the way that I did is I basically integrated it. Okay, let's see if we can figure out a way to explain this. Velocity. I don't want to say area under the curve though. I almost want to avoid saying area under the curve because it's not a it's a straight line that which might confuse them, and I feel like if they're not in a calculus-based physics class, it's going to really confuse them. So the person clearly they got part B right, so I assume they do know how to do it when there's say derivative then no. What I did for this problem this problem is split it up into two, get the positive change in velocity, going from t equals 8.75 to 10, then subtracting out the negative change in velocity going from t equals 14 to 15.5. Up with an overall negative number. You just do it from 8.75 to 15.5, you can get a weird result potentially. Okay. Let's see if if that makes sense. I hope it does. It can be taught in many different ways, though, I would think so. Oh, was there a question that was posted? Okay, no, it was just a person who joined. Welcome in. I'm sure there wasn't a question in my Discord. With the same person I'm seeing all over these threads down here. Oh, what's this? It's linear algebra stuff that I don't understand. I don't know what their question even is. Let's not. Oh gosh, what is this? Oh yeah. I have to make a new account. Oh no. That sucks, Aller. Yeah, I did kick your account out of the Discord just to make sure it wouldn't spam anything else, but you're obviously welcome to rejoin as soon as that was you? Oh, okay. Yeah, that sucks that you got hacked. Yeah. I mean, it might be overkill if you don't use Discord for anything important, but there is like two-factor authentication if you want to really prevent it from happening again. God, I don't know. Yeah, it sounds like a pain to deal with. All right, underscore. Thanks for hanging out and for helping me out and discussing. Hope you sleep well. Thanks for the follow. Is that stats? I've been going to. Oh, hey, follower goal 525. Well, thank you, extra. That's definitely not stats. I don't know which one you were. I was on when you were saying that. This index one, that's not stats. That's like some algebra thing or something. It looks like, or induction. I don't know. This one with the weighted average, I guess would count as stats. I just feel like whenever there's like these like kind of weird applied questions, things get kind of tricky. So I often avoid that one, avoid ones like these unless there's a very I feel like it's a clear answer that I can think of, but it's really hard to give clear answers when someone's like working on a very open-ended project that I don't have all the context for. Oh my gosh, look how many new ones have been up since I was going through the list. Oh no, not composing functions. I've had enough of this. I mean, if it's a simple version of composing function, not having to prove limits involving them, then, you know, I can be persuaded, but I don't know what the question is. I should probably look at what the actual question is saying. F of G, G of F, F of G, G of, okay. Composing them with each other. F composed of G. Wait, which one? F is the linear function, so it's just 5 minus this quadratic. I think they did the reverse. They put the quadratic right next to the 5. To get f of g of x, wherever you see an x in f of x, switch it out for g. Since f of x equals 5 minus x, we need to replace x with g there. So f of g of x is equal to 5 minus, then g is 4x squared plus x plus 6. 4x squared plus x plus 6. Looks like you inserted g of x just next to the 5, but that isn't how you do it, I guess. Feels a little bit blunt, but I'm just going to say that, I think. Hopefully this makes sense. They answered their own question, I guess. So sure, Barry Choi. That's cool. They got SPQ's idea. It's great to see. There's someone else who I replied to right around here. Yeah, basically, yeah, God, okay. I would do it twice, once with the positive part from 8.7 to 10. I would do that formula twice. And then again, for the negative part from 14 to 5.5, or 15.5. Okay. Switch the 5 around, but there's still the minus sign to worry about. So it'd be f of g of x equals minus 4x squared plus x plus 6 plus 5. Personally, I'd start from f of g of x, oops, like that, equals 5 minus 4x squared, it's x plus 6. Then simplify it like 5 minus 4x squared minus x minus 6. So minus 4x squared minus x minus 1. Okay. And Rishi, what would be your favorite topic to solve, say, algebra, calculus, trig? I say my favorite topic is probably differential equations, which is just like a part of calculus. In general, I like a good calculus question. That, but you'd add them to get the total change. The minus is just for calculating the changes individually. Oh God, I don't even know where you start with it. Probably by studying. Oh, that's a pretty open and shut case right there. It probably got closed on them while they were still like typing. It's kind of a weird one. What the heck is happening here? H of x equals f of x plus x times g of x, then h prime of 3. Oh, interesting. So I like what they did with getting the product rule. Why is f prime 1? Because they're evaluating it at 3 already? I don't know why they did that. Let me just make sure. I don't want to abandon the people I was already talking to. Glorified simple mathematics? I guess so, yeah. I don't really know how to reply to that, so I'm just going to leave it, but... What else was I talking to? I don't think I replied to anyone down there. It was just this one and Pumpkin person. Yep. Sorry for not explaining that more. Perfect. Oh, you know, there was this one. Why did they get that one there? Oh wait, is that a Y? It's hard to tell. Let me make it a bit bigger. Hard time reading their work. Someone else beat me to it. I saw. Oh no, okay. Okay, yeah, we're good. Okay, what is that in the red circle? It looks like a 1 plus. Okay, someone said that f prime is equal to 1. Which... Nowhere... Oh, wait. Oh, f prime is always negative 1. That's true. Maybe that's what they were trying to do here. G prime of 3... what is that? The slope is 2. Did they not calculate G prime of 3? I don't think they did. G of 3 is indeed 3. Okay. Oh, they said the answer is 4 plus G prime of 3, 3. Okay, so there's 2 issues here. You were close, but the first issue is that f prime of x is negative 1, not plus 1, because it's next you can actually calculate G prime of 3 because it's the slope of the line at x equals 3. Looking at the part of g of x around x equals 3, the slope is 2. So you can plug that in to get just a number for the answer. Okay. Pumpkin... Wait. No. Pumpkin. Okay, they got it. Oh, no? It is dot close. I'm not sure. I don't feel qualified to answer, though. Oh. So I got the forward t part, and I don't know if the rest is right. Derivative. I don't see what this person is saying. The answer is 4. I didn't actually calculate the answer, to be honest. Negative 1 plus 2 times 3 plus 3. Negative, all right, positive 8? I think it's -1 plus 2 times 3 plus 3 equals 8. Because 6 minus 1, or 9 minus 1 is 8. Yeah. Okay. Either way, I think we'll call the stream here for the day. I've been going for a long time. So, if someone gets back to you on the math, the Discord, I'll just get back to them offline. All right. Let's go raid Zach, though. Actually, for YouTube, I'm going to cut the stream off here. I highly encourage you, if you are in the YouTube chat, go over and check out Zach's real analysis class over on Twitch, starting basically right now. If Nightbot ever decides to actually post it. Come on. And whether you're chatting or lurking, I appreciate you. Come on. Nightbot, can you just work for once in your life? I don't mean to be rude, but like, it'd be great. There it goes. And for some reason, I don't have Zach's Twitch link in there. There, that's the link. All right, so YouTube, I'm out of here. Thank you, and I'll see you around.